Technology, MIT University, Uttar Pradesh, Noida. As one of the leading global universities, MIT University is dedicated towards its responsibility of imparting its students with strong foundation and a platform for empirical inquisition. With this agenda, Confluence 2026 intends to bring together professional academians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovation, share research results, and new direction in the field of next generation technologies. It's our, may I invite Professor Dr. Neha Tyagi to present this happening to our esteemed speaker, Professor Dr. Sartaj Sahni, University of Florida, USA.
Yeah, good morning. Welcome, sir. We are welcoming you in Conference 2026. Yes, please carry on, sir, your session.
It's a great privilege and honor to have among us Professor Dr. Sartaj Sahni. Dr. Sahni is a distinguished professor of computer and information science and engineering at the University of Florida and a member of European Academy of Science and the Academy of Engineering, Science and Medicine, Florida. He is a fellow of IEEE, ACM, and AAAS and a distinguished alumnus of IIT Kanpur. Dr. Sahni has received numerous awards, including the IEEE Computer Society Taylor K. L. Booth Education Award, W. Wallace McDowell Award, ACM Karlstrom Outstanding Educator Award, and the IEEE TCSC Award for the Excellence in Scalable Computing. He has published over 430 research papers and authored 15 textbooks and holds 15 US patents. His research focuses on the efficient algorithm, parallel computing, interconnection networks, design automation, and medicine algorithms. He has served as the editor-in-chief of ACM Computing Surveys and the Journal of Parallel and Distributed Computing, and is the electoral board of 17 journals. Now, I request Dr. Sahni to kindly address the gathering with his insights on the topic of data structures and algorithm for fast multi-object tracking. Sir, due to time constraint, we request you to consider your session within 20 minutes of time.
Okay,
Please, sir.
yeah. All right, may I start?
Yes, sir.
Yeah, okay. Well, thank you very much for the introduction. I do want to thank the organizers, in particular, Dr. Garima Agarwal, for inviting me to give this keynote. And I will try to do my best to condense this thing down to 20 minutes. So the work I'm going to talk about was funded by a project from the US Army. And we started with a piece of code that did multi-object tracking. However, the performance of the code wasn't exactly what was needed, and we were tasked to improve the performance of this code by transitioning the code into a parallel environment. However, when we looked at the code, we saw there were several opportunities to improve its performance in a single core. And so we spent some time improving its performance in a single core, and that's what we're going to talk about today. And subsequent to improving the performance in a single core, we have started to look at parallelizing it to get even further performance improvement. Our team consists of 2 PhD students, Yash and Ghani, and then there are 4 faculty members as listed here. One of these is with the US Naval Research Office and another one with the University of Missouri. The problem, we're given a video, and the video has a large number of frames in it. The objective is to track objects of interest from one frame to the next. So we'd like to be able to see where objects of interest are in any particular frame, seeing how they're moving. As you can see in this video here, we are in this case tracking cars, and this tracking involves a number of high-level tasks. First, of course, in each frame, you need to identify and locate the objects of interest, the things you want to track. Once you have done this, we typically throw a bounding box around the object and then track the bounding boxes. So track the bounding boxes across the frames of a video, keeping in mind that objects may temporarily disappear because of a occlusion, and then they could reappear several frames later. And that new objects may appear in any later frame. So it's not that all the objects of interest are present in frame one and you just follow these through all of the frames. Multi-object tracking has several applications. It could be used in surveillance, so keeping track of the movement of suspicious characters, automatic checkout, where you want to track customers through a store, making a note of everything that they put in their cart, and then billing them automatically. Can be used in self-driving cars to estimate the speed, and also to avoid collisions. Now, the algorithmic tasks that we focused on were things like intersect over union computation. So if you go back to some of the tasks I listed earlier, the first step is to identify the objects and then put bounding boxes across them. We did not look at the portion of the code that actually identified the objects, put the bounding boxes. We kind of started with the bounding boxes. So you have bounding boxes in one frame, and you have bounding boxes in, say, the next frame. Using information on the velocity of the objects, you can project where the objects in one frame would be or are expected to be in the next frame. So using these projections, we look at these bounding boxes and compute the intersection over union of pairs of rectangles or boxes. And the higher this ratio, the higher the likelihood that that particular pair corresponds to the same object. Okay. So the IOU computation gives you a weightage for the likelihood that a box in one frame corresponds to a box in the next frame. To actually get the correspondence, you solve a linear sum assignment problem, which is really a weighted matching problem in a bipartite graph, where the vertices on one side represent the projection of boxes from one frame, and the vertices on the second side represent the location of boxes in the current frame. And then the edges give you the likelihood that you have a match between a box in one frame and a box in the other, and you want to find a matching that maximizes the sum of the weights. We use Kalman prediction to predict where boxes will be, and then there is a process to update the Kalman coefficients. So these are the algorithmic tasks that we focused on. I will spend a little bit of time talking about the IOU computation, and then very briefly mention the kind of improvements we obtained for the other three without actually spending any time telling you how we did it. So the IOU computation, as I said, is frame-to-frame object matching. You're given two sets of bounding boxes, BB1, bounding boxes from the first frame, and you've already projected where these should be in the next frame. BB2, location of bounding boxes in the current frame. And then the objective is to find all pairs of overlaps in the boxes in the two sets. A very simple solution is to just look at all pairs of boxes, and for each pair, compute the intersection of the areas, compute the union, and divide the two. That'll give you the intersection over union for this pair. This is going to take you n squared time if you have n boxes in each frame. Another strategy, which, and I guess I should mention, this is the strategy that was used in the code that was given to us. you can improve the performance of finding the overlapping rectangles by examining the edges in these overlapping, or in these rectangles, bottom to top. So let's say the red boxes represent boxes in one frame, and the green boxes represent boxes in the other frame. If we examine the horizontal edges bottom to top, then when you see a bottom edge, we'll say that at that time we will open the box. When you see a top edge, we will close the box. Okay, so we keep track of open boxes. So as you move upwards, whenever you see a bottom edge, you open a box. When you see a top edge, you close a box. So moving upwards, the first top edge you see is this green edge corresponding to D. And we can determine the boxes that it overlaps with, the red boxes, by looking at the open red boxes with which you have a horizontal overlap. So you get BD as an intersection. Once you've done that, you close this box, so it's no longer an open box, so that when you come and see this top edge, you don't report BD as an overlap again, because whenever you see a top edge, we're going to look for open rectangles or open boxes of a different color. And so you don't have an open green box. On the other hand, when you come to this top edge here, this green rectangle is open, and so we can report that E and A overlap because there is an edge overlap in the horizontal direction. Similarly, when you see this top edge, the open green rectangles are E and F, and you can report the overlaps between E and C and F. Okay, so the strategy is, instead of looking at every pair of rectangles, we will examine the horizontal edges bottom to top and get the same result. And this is actually something you can do efficiently using a data structure called a priority search tree. Here, the data structure stores elements that are a pair of numbers, X and Y. You can think of these as coordinates in two-dimensional space. You can insert new pairs and delete new pairs efficiently. And you can perform an operation called enumerate rectangle, which gives you all the points that lie within a rectangle with the left boundary XL, right boundary XR, and top boundary Y sub T. So for example, if this is your collection of points, then here is your left boundary, here is your right boundary, here is your top boundary. The bottom boundary is assumed to be 0. So enumerate rectangle will give us these 4 points that lie within the rectangle. Mathematically, it's defined by these equations. Okay. So enumerate rectangle allows you to enumerate the points within a rectangle, and this enumeration can be done quite fast. It takes time that is logarithmic in the total number of points, plus the number of points that actually lie within the rectangle. Now, the online intersection of line intervals problem can be mapped to enumerate rectangle. So in the online intersection of line intervals, you're given a collection of intervals. An interval has a left point I and a right point J. And you need to answer queries of the form, which intervals overlap with another interval that begins at U and goes to V. Let me illustrate this by an example. Right, so here I've got 6 intervals, A through F. Interval A begins at 1, ends at 3. Interval B begins at 5, ends at 7. Okay. And I want to know which of these intervals overlaps with the interval from 2 to 4. So that's the interval from 2 to 4. And so the ones that overlap are A, C, E, and F. So I want to report those. Okay. To do this, using a priority search tree, I'm going to map these intervals into points in two-dimensional space and then use the enumerate rectangle function. Okay. To do the mapping into two-dimensional space, if an interval begins at I and ends to J, I will map it to the point xy where x is j and y is I. So I'm going to kind of invert the left and right points. X will be the right point and y will be the left point of the interval. Okay. So in this case, this collection of 6 intervals would get mapped to these 6 points. E begins at 1, goes to 2, so it's mapped to the point with x equals 2, y equals 1. A begins at 1, goes to 3, so it's mapped to the point with x equals 3, y equals 1. Okay, so this is 2, 1, that's 3, 1. C here is 4, 2, okay, and so on. Okay, so I do this mapping, and having done this mapping, I then run an enumerate. So I want to find all my intervals that overlap with the interval that begins at U and goes to V. So the enumerated rectangle query takes this form. So for example, if you want to find all of your intervals that overlap with the interval 2 to 4, it will be enumerate rectangle where the left endpoint is 2, right endpoint is infinity, and the top is 4. Okay. So in terms of my mapping here, left endpoint is 2. So that's 2. You recall that E was the point 2, 1. So that's x equals 2. And then the right boundary of the rectangle is infinity. So it's way off to the right. The top is at 4, rectangle. Okay. And so I will get all of these. And we can see that you've got E touches the rectangle, so I'll count that as an overlap. C touches the rectangle, F, A, and B, and those are the ones that get reported. You can see that this is this query will always work by looking at the points that are excluded. Okay. So the points that are excluded, that's the point that are outside of the rectangle. You have those that are to the left and those that are above. Okay. If you're above, that means that you start after V. Okay. So if an interval starts after V, it obviously cannot overlap anywhere from U to V. The left endpoint here, if you lie on this side, you must be finishing before 2. Okay. So again, if you finish before 2, you cannot overlap with the interval from 2 to 4. So at least we can see that the points that are excluded clearly don't overlap. And then it's a simple matter to go from there to see that the points that are included do have an overlap. Okay. Right, so this data structure allows you to find overlaps of intervals. It also allows you to insert new intervals and remove old ones. And that's also needed by our solution for the intersection over union problem. Because whenever we see a bottom edge, we need to open a box, which will correspond to inserting into a priority search tree. And when you see a top edge, we'll need to close a box that'll correspond to deleting from a priority search tree. Right, so the algorithm takes this form. We're going to sort the edges in increasing order of Y. We're going to use 2 priority search trees. One is going to keep track of bottom edges from one frame. The other one is going to keep track of bottom edges from the other frame. We're going to examine the bottom edges in the sorted order, the horizontal edges in sorted order. And if the edge you're currently examining happens to be a bottom edge from the first frame, we will insert it into the priority search tree for that frame. If it happens to be a bottom edge from the second frame, we'll insert it into the priority search tree for that frame. If it's not a bottom edge, it's a top edge. If it's a top edge, we want to look at the open boxes in the other frame. So if it's a top red edge, you want to look at the bottom edges in the green frame. And if it's a green top edge, you want to look at it in the red one. Okay. All right, so we need to be able to use two priority search trees. We need to be able to insert new intervals. We need to be able to delete intervals, and we need to be able to do rectangle, enumerate rectangle. And all of these can be done in time that is n log n being the number of boxes plus the size of the answer, which is the number of overlapping pairs. Okay, all right, so we can reduce the complexity of finding the IoT values from n squared n log n plus number of overlapping pairs. Now that's nice. An alternative to this is another solution, which is really a heuristic, where you sort the boxes by their left edge, and then you examine them, and you don't really need to examine all pairs, because since they're sorted by the left edge, if some box is too far away from the currently active box, you don't need to look at any boxes that are further away. So I'll let you check that out later on your own, since we are kind of running out of time. But you can do a heuristic whose complexity is still n squared, but on practical data sets, it can actually run quite fast because it eliminates comparing many pairs of boxes. And actually on the videos that we had, this heuristic scheme that has a complexity of n squared actually performed better than the priority search tree scheme, which had an n log n size of answer complexity. All right, so moving on to the linear sum assignment problem. Typically, this is done using a dense graph representation. We modified that to obtain a sparse graph representation algorithm. I won't go through the details. The Kalman prediction, this was coded using the textbook equations, which involve matrix multiplications and additions. We examined the matrices and found these were quite well structured, and so you could do it without using general matrix multiply and general adds. And we were able to reduce the total number of arithmetic operations from 707 multiplies and 651 adds to 0 multiplies and 25 adds. We looked at the Kalman update part, and again, it's typically implemented using standard matrix.
Excuse me, sir, am I audible?
Multiplies and adds, again, using the structural properties of the matrices involved. You could do a customized code, which
Sir,
reduces
am I audible, sir?
the number of arithmetic operations significantly, as shown here. Hello?
Yes, sir. Am I audible?
Yeah, I can hear you. Yeah.
Yes, sir. Could you please wrap it in 5 minutes, sir?
Yeah, I've got about 5 minutes left. Yeah. Okay. All right. So moving on to experimental results, we first used pairs of frames from a data set called Wizdrone. And if you had about 50 objects per frame, we were getting a speed up of about 21 relative to the code that we started with. If the number of objects per frame was about 5,000, you're getting a speed up of about 85. Running it on a complete video, this is a different video called the bird video. The original code took about 56 minutes to process all the frames, whereas with our algorithmic and data structure improvements, we could do this whole thing in 8 seconds. So it's a pretty substantial speed up through the use of optimized algorithms and data structures. If you want to read more about it, there's a publication that we have from last year. There's also a journal version that we are kind of finishing up right now and should be ready hopefully in a month or so. So to summarize, using appropriate data structures and algorithm design methods, we were able to obtain significant speed up for multi-object tracking. We are currently looking at obtaining further speed up through the use of parallel processing. Our first step is to look at multi-core, and then we plan to take a look at a GPU option to get further speed up. Okay. All right, so that kind of concludes my talk. I'd like to thank you all for listening, and if you have any questions, I can try and answer these. Thank you.
Thank you so much, sir.
Okay, yeah.
Thank you so much, sir, for your insights, especially on the topic of line interval explanation. May I invite Professor Dr. Neha Tyagi to present our esteemed speaker, Professor Dr. Sartaj Sahni, as a token of gratitude.
Okay, thank you. Yeah.
Thank you so much, sir.
Yeah, thank you very much for inviting me.
Accept the Tulsi sapling from Amity site.
Yes, thank you. Yeah.
When you will come, we will give you as a physical in person. Now
Sure.
the virtual accept this. Thank you so
All
much,
right,
sir.
thank you. Yeah.
Students get very insights from your talk. Thank you so much.
Okay, thanks a lot. Yeah. Okay. Yeah, goodbye.
Meanwhile, Backdrop लगा। सर backdrop
हाँ लगा रहे हैं वो लगाना
मेल कर दिया
कर दिया
mail किया। हाँ जी please।
हेलो 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 पूछना हेलो 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 ठीक है ऑडियो मत करना ठीक है इसको डाउनलोड कर लो इससे ऑडियो डाउनलोड करना आप माइक माइक पे बोलोगे कहीं से बोलोगे अब इससे ऑडियो ज्वाइन मत करना आप कहीं भी किसी भी माइक पे बोलोगे तो
Keeping the flames of insightful discussions alight, now it is our great privilege and honor to have amongst us Professor Dr. Chanchal K. Roy, University of Saskatchewan, Canada. Professor, welcome, sir. We are audible to you, right?
yeah thank you yeah
Yes, sir. So, Professor Dr. Chanchal K. Roy is the director of the Industry Stream Multi-University NSERC Create Graduate Program on Software Analytics Research, co-director of Software Research Lab, and professor of Software Engineering and Computer Science at the University of Saskatchewan, Canada. He is the lead author of the widely used Naked Code clone detection system and has published over 240 refereed papers with 30,000 plus citations and an H-index of 52. His research focuses on software clone detection, software evolution and maintenance, recommender systems, and big data analytics in software engineering. Professor Roy has supervised 113 highly qualified personnel cross academics level. His work has earned 3 most influential paper awards at SANER 2018, ICPC 2018, and SANER 2021. He has received multiple research excellence awards and secured over $6 million in external research funding. Now, I request Professor Roy to kindly address the gathering with his insights on the topic of building a global research pipeline, family-inspired mentorship, and LLM-driven research. Just a small request, sir. Due to time constraints, we would like to conclude your session in 20 minutes. Is that okay?
in 20 minutes
Yes, sir.
okay yeah I will try to finish in 20 minutes okay I will just go quickly yeah
Thank you very much, sir. Please.
okay yeah thank you thank you so much for the invite, and of course, each year I talk here. It's really a real pleasure talking in at this conference and to the students of this Amrita University. So thank you all, and also thanks all the participants who are here and willing to hear the talk. So yes, as we are shortage of time, I will go quickly. But I want to focus more on recently I gave a talk at ACM SIGSoft webinar. So they asked me, how do you build, this global pipeline, why so many students come to your lab and how they are so successful. What are the key reasons for that? So, and as part of this, my talk is today about, we talk about a lot of technical talks a lot of time, but today's talk is more about, mentorship. But before that mentorship, I want to just highlight some of the students in our lab that, doing LLM-driven research and where we could go. It's more of, giving students a little bit of flavor. If somebody comes here, we are actively looking for MSc students, PhD students, and postdoctoral fellows, and to give them that what we have been doing and, how our lab is and why our students are successful and all those things. So of course, we work together. We have 2 labs. We work together closely with Dr. Banani Roy and myself and another Dr. Kevin Schneider. We have about 30 students right now in the lab. And these are the persons, myself, Kevin Schneider, and Dr. Banani Roy. And the number of SQP, it's just my SQP. They have their own SQPs. SQP means like the student I supervised, And this is like our research area. As you can see, clone is one of my primary research area, but I also do a lot of other work in software maintenance and evolution, software engineering, recommender systems, different kinds of things. But what is clone? So as you can see here, three of Chancel Roy, and it's no idea. It's not generated by AI though. It's created a while ago before LLM came. So it's one of these like software clones, like duplicated fragments of code. So why clones are there, why people copy paste, how much they modify, what are the consequences, how can we manage them, how can we detect them, how bugs are being propagated. So all those different things could happen with when you copy and paste. And there are a lot of students have been even currently working on clone. And there are a lot of different tools out there. One of the problems with different tools is that people do not know how good that tool is. So what is their precision and recall. So we did a lot of work, but it is just I'm talking about in terms of LLM. And so we also did a lot of work on how good the tool is, what is the precision recall, because one of the most challenging part is what is the recall, because for measuring recall you need to know in a software system. Let's say if you have a software system, then how many real clones are there. So if you have similar code fragments, how many reals are there? And if you do not know how many reals are there, how can you say that your tool really detected all of them? So in order to solve that, there are a lot of different benchmarks available, and most of them benchmarks are also from our lab, actually. And but this benchmarks was created before, and they had their own problems, like they are not reliable, they have a small data set. They cannot be adapted to different languages. Maybe you only have one language you can support. So we then made use of GPT after ChatGPT came in that early on, and then we thought, okay, how good ChatGPT is in creating clones, or how reliable they are, how trustworthy that code fragment is. Do they really match with the real world? How developers copy and paste, right? So do they really match developers' behavior? And then we in order to do that, after we use different prompts, we actually verify them. We use functional testing. We really did dynamic testing. We also use another machine learning based tool, clone cognition, that can verify the code fragments as per user's preference, because we already trained it. And then of course we also did manual validation. And what we found out that actually even GPT-3 was good in creating cross-language clones, like like if you have clone in a code fragment in Java, then finding out or generating a code fragment in another language, let's say in C. But it is still not good in semantic clone. Semantic clone means, let's say you are creating code fragment that is one fragment is written in a different way, another is written another way. Let's say one you have written with for loop, another you have used recursion. So they do the same thing. They were both, let's say, doing bubble sort, but they are doing in a different way. So GPT was good, but not very good, even in our experiments. We also did some translation from one language to another recently with algorithmic based, but still, GPT is really good if you follow algorithmic structure instead of direct translation, for example. So lessons learned, you need to give good context and good prompt, of course, but context is the key. And it's still for semantic clones, GPT is still kind of struggling. And then we also looked at whether classical detectors, like those are before AI came, whether they are good at in the AI era. Because in AI era, when AI era came, there are a lot of different tools. When AI era came, we see new kinds of clones, new kind of similar fragments in the source. And then we want to see whether the clone detectors that were detected before, whether still they are good. And we figure out that the classical detectors are still good if you can, compared to the recent detectors with AI based. The classical detector could be still good if you can really apply some, strong normalizations. Normalizations mean you have to try to do some source transformation and make, try to remove the differences between the code fragments. And then maybe you have to really make sure that you're using multi-evaluation benchmark, AI and human in the loop, context, more context. Then maybe you can still use the traditional clone detectors, but also you do detect clones in the AI era. But in the same time, you're getting the benefits of traditional detectors because they can scale, they are robust, they are already built, they are reliable. So that's a good thing we have, and we figure it out. And we have students also, they are working on bugs. And of course, again, the focus is on LLMs. Some students working on bugs, just simply using fine-tuning transformers in finding out runtime errors, or like, finding bugs in the IDE, or like finding, localizing bugs. And nowadays, we also have multimedia bugs, like even, not just a simple bug report with text, but you might have, some images like this here. And we are using GPT to see how, using those multimedia bug reports, how can you localize bugs in the code base, like finding out where the bug is. Because when you have millions of, lines of code or billions of lines of code in a software system, how can you ensure where the bug is? So we are using LLMs for that part too. And sometimes in the issue tracking systems nowadays, people are using LLM everywhere, right? And issue tracking systems, people are also using LLM. We have done it also. And we looked at, we explored what is going on, let's say in GitHub, how people are using it. And we found out still now LLM is only being used for idea generation while they are, resolving the issues. And that's kind of a bit problematic because it's still not up to there. So there are a lot of research potential when in the IDs for for LLMs, for ITS, for issue tracking systems. And of course, there are students who have been working a lot of different other areas. Some students working in, like say, reproducibility. Recently, we looked at, actually this year it is going to be published at ICSI. We looked at, when you have a paper, you submit a paper and you submit a replication package, but often, they are not really reproducible. Somebody is trying to run your package. You said it will run and it will give you the output, but it is not really giving you. So we looked at it and we provided suggestions how to do, provide the correct replication package, what rules to follow, and as what people should follow as in the open science. If you want to make people, work with your data, if you want people to cite your work, then you have to let them, run your system. So you have to follow some guidelines. So we provided that one too. But then, along with all those different LLM-based work, what we are mostly looking at, even because LLM is being used everywhere, even like, people are talking about 85% like of the developers are happy with like using even Copilot. And I mean, LLM is everywhere, right? But the question is, training an LLM is very expensive because, the hardware cost, timing, all those things. Like even just training the GPT-3 cost around 4 million. And then how can you do it, in a standard hardware? How can you do your own? How can you, train of your own context? So in order to solve that, one of the things we have, this is actually going to be, this is just got accepted at FSC this year. And even for, like you have, forget about training, even for, there are hidden costs because every day, every time people are using, those LLMs, pre-trained models, like even Amazon says 90% of their cost is on machine learning and always having inference. Or like Facebook says 2 trillion inference per day. That means that they're using too much power and, or too much computing all the time. And the question is, can we really solve that problem? Because if they are too expensive and, not only being expensive, not only being, time consuming, but then another thing is coming about this sustainability, increasing carbon footprint. So carbon dioxide, for example. So we're gonna look for, okay, can we really, make a model that can be, that can produce zero carbon, for example. And if you can produce zero carbon, that means that you will have less memory, of course, you will have less latency, you will have less energy use, right? So that means optimizing the model. So we did that in a pipeline, which we call it carbon tax, transformer models or carbon tax pipeline. And where we try to use the traditional thing, like knowledge distillation or like, pruning, all those things. But what we did, we used this neural architectural search, but in the context of, task specific. We have 3 different tasks: column detection, code summarization, and code generation. And then we looked at, okay, well, these models could be pruned, or they could be, you can easily optimize them for different tasks differently. So task is specific. So based on our teacher model, and then we can, based on the tasks we have, we can actually generate the model, or we can, train the model, or we can optimize the model very, very efficiently. And we found out that our optimized model is much better, because if you look at the other models, now we have just in the megabyte. And in terms of parameters, we have just, so in a fraction of parameters. Or if you look at more, the performance, for example, the performance is not bad. So like our system, although we have optimized model, like 1.6 mega only here, then our performance is not bad compared to the other model. Those are really heavyweight models. And even for all those different kinds of tasks, our model is giving us wonderful outcome too in terms of performance. And in terms of memory, you see our memory, like memory used for other models is huge, but in our model is only a simple, like a fraction. So if you look at the carbon, the paper is about carbon tax. And if we do normal, our carbon tax, it is kind of emitting zero carbon compared to the others. And it is running, of course, in the standard hardware now. And then in the same time, if you look at the other model for those same kind of task, they have this kind of relative. So it is 13% more than our model. So it's kind of all shows, and sometimes it could be, you see, 400, these models. So this is kind of one of the things we have been doing recently, like even, because LLM is so popular and everybody is using it. But you're also looking at ethics in AI. So because LLM, you cannot just use LLM everywhere. You have to follow the ethics, right? And we conclude that we need to always talk about, risk-sensitive governance for each of the things we do with LLM. And of course, I'm not talking about all those because of the time issue. I am going. There are other students in the lab, and of course there are other research. But then I'm going for that, as I was noting, why we have been kind of successful with so many students, graduating so many students, and how students are getting, different awards, winning, getting jobs. Some of our alumni, they are, faculty members or working in different companies. So what is the key? That was asked by SEM 6 of recently to me, and then I thought, okay, what is the key? Then I reflect myself what I do, and I found out that actually we kind of inherently follow a family-like lab environment. So how many minutes I have right now? Sorry, 10 more minutes or?
No, you can conclude in 5 minutes.
Okay, 5 minutes.
Yes, sir.
Okay, so I will go quick. So like, if you have a family-like lab environment, then you can, and then if you have a strong support network means, of course, we also, when we hire students, then we need recommendation letters, and we need people like, Dr. Garima Agrawal or Dr. Neha Tyagi to tell us, okay, take this student. So we use that support network. And if we have a good support network, we make use of that support network, and we get a strong students, and we get a strong, good research. But the core value is family-like lab environment, a holistic, human-centered approach, because our students are not just the lab members, they are like our family. And they are building a culture of care, empowerment, and excellence. And by doing that, if you have a family, family has a responsibility. Each member get their own responsibility. They are ensured that there will be long-term care for each and everyone. They know that there will be trust, and they know that it is a shared journey. No one is alone, right? And belonging is the foundation of academic courage, and that's the core principle that we follow in our lab. Family doesn't mean that we are invading a student's personal life, but it means that we're helping them, we're respecting them, we have compassion, right? And of course, the core message, right? If you have a family like lab environment, then you will have a care, and care enables trust. Trust enables empowerment, right? And empowerment enables excellence. That's how we do good research. So that's how our students excel, not only in the research, but also in their afterwards, in gaining awards, getting jobs, being established in their professional life. And of course, we support them in different ways. I'm not going in details, because we have to support the students. You cannot really, get good output from students if somebody is, drowning, right? And we intentionally promote, culture, like our South Asian culture in our lab. And by doing that, we increase trust, we reduces isolation. By doing this, different programs, we automatically enhances the collaboration between the students, and we build lifelong networks. Even we, arrange marriages for our students, because if both students are in our lab, our students, and we said, okay, their parents are not here and back home in Bangladesh. Many of the students are from Bangladesh, and I really want many of the students should come from India, and which is why I'm trying to give this talk. And we really would like to see a lot of people from India, like in Bangladesh. So even we give a special priority to the couples. And right now, we have 9 couples kind of graduated or have been currently in our lab, so both of them, and we also arrange marriages. So if somebody is interested, please talk to us. And we focus on culture over collaboration, because we know that if we focus on culture, if they get together, if they mingle together, they will start collaboration. That's the principle we follow. And of course, we respect, right? I guide the boat, but they will choose the destination. They will choose the topic. They will do the research. They are the owner of the research, right? They are the owner of the research. We provide, growth over prestige. Sometimes we even publish in, we don't need to publish in a top tier all the time, because we want to, make the confidence of the student. We want to, so that the students do not get, frustrated, right? So we always try to empower the students different ways. Ownership of the work, giving them leadership responsibility, encouraging them publicly, and empowerment kind of is the vaccine. That's what we, against failure. That's what we try to, follow in our lab all the time. So we ensure that confidence is not inherited. It is engineered. We always try to build their confidence in different ways. And how we do that? We recruit, as I said, we have a support network. Our students help us. Most of the actually students also help us to recruit our new students. And within the support network, we of course look at references, and we look at references. I'll talk more about this maybe in a minute. But we have the support network, and I welcome our support network from India. Like any professors that you work with, build your trust with your somebody locally, and they will advocate for you to us. And we have a big support network. We believe in them, and if they recommend us students, we right away believe in them, and we hire them. We try our best to, at least. And these are a lot of support network. Of course, when you have a strong support network, we get a strong students. That's our benefit, And we use the students in hiring the students, because we ask our current students whether this student is good, or whether they have they know somebody in their network, right? So that's how our network supports. We build the ecosystem over time. And of course, we also looked at the writing quality of the students, or the emails, how they write the emails, whether it is a generic email or.
Excuse me, sir.
Yes, please, yeah.
I'm really sorry to interrupt, but
Okay, I will. You're saying I have to finish, right?
Yes,
Okay,
sir.
I'm going to finish it. Yeah. So I am some of the things we looked at, some fact checks. Yeah, so that's the core, that we provide care, we provide trust, respect, freedom, empowerment, and community. We work as a community, no one stands alone. We make sure that leadership is a service role, not a status. We support, empower, we help them grow. Everything else automatically comes. Excellent research comes automatically. And thank you. Yeah. So thank you. I'm done.
Thank you very much, sir. That was a very insightful session. Now, may I invite Professor Dr. Neha Tyagi to present a memento to our esteemed speaker, Professor Dr. Chanchal K. Roy, as a token of gratitude.
Okay, thank you.
Thank you so much, sir. You have given very great insights to our students, and our students definitely will collaborate with you, whatever you have given the things for the collaborations. Thank you so much. It's a virtual sapling for coming person. We will give you in person this Tulsi sapling. Thank you so much.
Thank you. Yeah, thank you so much. I really appreciate this Tulsi sapling. We always, pray at home, and it's really great to see that Tulsi sampling. And thank you, Dr. Natyagi, and Dr. Gorima Agrawal as well. I'm really glad to be here to this talk, and I would really appreciate if somebody, some of your students contact us, and we want to build a network with Indian institutes, and with bring as many students as we can. And I know that India has a lot of talents all over the world, and we do not want to miss it. We already have, but I'm saying we want to bring more. Thank you. Yeah.
Thank you. Thank you so much. Thank you, sir. Nice.
Thank you.
With this, we conclude the session. We hope that it was enriching and informative experience. I once again, on the behalf of the fraternity of Amity University, Uttar Pradesh, thank all the guests and dignitaries for their significant presence. We would also like to thank the students for their cooperations. Thank you very much.
Yes, students, thank you so much for your patience. Right now, you have to move to E2 body, and your next session will start here at 12:15. So you will be here at 12:15. Okay, so please move to E2 body. Here we have the inaugural function of this conference. And 12:15 means 12:15. You all will be here next session. Okay, thank you so much.
I wanted to.
Can you hear me now?
Sir, am I
Can
audible?
you,
Sir, am I audible?
am I audible?
Yes, sir, you are. Sir, am I audible?
I am not able to hear you.
Hello.
Yes, yes. Yeah.
Am I audible, sir?
Yeah, yeah. Now it's okay.
Yeah, okay. Welcome, sir. Welcome. Happy New Year.
Thank you. And in advance Republic Day greetings also to you.
Thank you, sir. Thank you so much. Start.
Sir, ladies and gentlemen, at the outset, I express a warm and respectful welcome to the 16th International Conference, Confluence 2026, on the recent trends in artificial science, innovation in cybersecurity, AI, digital forensics, and advancement in IoT, science, University of Uttar Pradesh, Noida. Cities is responsibility of students with strong foundation and education. With this agenda, Conference 6 intends to bring together professional, industrial experts, researchers, and interest to discuss various emerging trends and innovation, share research results, and adoption of information technologies. It's a great privilege and honor to have among us Professor Dr. Vishwakarma, Senior Engineer, Solution Elements, North Vancouver, Canada. Dr. Vishwakarma is a professional engineer in British Columbia, Canada, and chartered in the Polish Elements, North Vancouver, Canada. He is an MD in Power Management and has conducted doctoral research in energy conservation at the University of West Indies. With over 3 decades of experience in the utility industry, with expertise in generation, transmission, distribution, asset management, and resource development. He has also served as the honorary Dr. Vishwakarma is an active member of the Institute of Institution. Now, and we request you all to come to the session with the topics of
Yeah.
Excuse me, sir.
अरे है भाई या चल रहा
Sir, am I audible?
Just to let you know, I am not able to hear anything. I don't know. Last time also and year before last also, your audio system had the same problems. And today also, this is the third year consecutively that your audio system is not working. You are able to see me, but it won't be, I wanted to make this as an interactive session because I can see a lot of students are there. I would have loved talking to them. Can you hear me?
Sir, am I audible?
Now you are audible. Now. Do something. You don't have a remote mic.
Sir, am I audible now?
Yes, you are audible now. But before that, no. What my question to you is, do you have a remote mic?
Yes, sir.
Okay, so at least what you can do, if somebody wants to talk to me, or if I want to interact with someone, at least somebody can take that, carry that remote mic, and then at least I will be able to talk to you guys.
Okay, sir.
I just want you to know, all students are here or faculty members are also in?
Right, sir.
Faculty members are also in, but majority of the audience, they are students. Am I correct?
Yes, sir. Majority of our students, and we have professors too.
All right. Okay. So you all guys, you are undergraduate student or you are postgraduate students?
So postgraduate students are here,
All right. Very good.
as well as undergraduates are also.
All right. But the specialization
Computer
there
computer science, data science,
and
and cyber students are here.
all right. Do you have biomedical engineering also at Amity University?
Yeah, but right now we don't have students here related to this.
All right. Otherwise, that would have been much better situation. Okay. I couldn't hear. Somebody was speaking something on the
Yes,
mic,
sir.
but I was. Have you already introduced me? Can I proceed now?
Sir, I would like to start again.
All right.
Yeah. A very good afternoon to all the distinguished dignitaries, respected professor, ladies and gentlemen. At the outset, I, Om Vinayak, express a warm and respectful welcome to the 16th International Conference, Confluence 2026, on the theme Recent Trends in Artificial Intelligence and Data Science in Empirical Inquisition. With this agenda, Confluence 2026 intends to bring together professional, academicians, industrial experts, researchers, and enthusiasts to discuss various emerging trends and innovation, share research results, and new direction in the field of next generation technologies. It's our great privilege and honor to have among us Professor Dr. Suresh Vishwakarma, Senior Engineer, Salish Elements, North Vancouver, Canada. Dr. Vishwakarma is a professional engineer in British Columbia, Canada, and a chartered engineer with the UK Engineering Council, currently working as senior engineer with Salish Elements, North Vancouver, Canada. He holds an MBA, a PhD in power management, and has conducted postdoctoral research in energy conservation at the University of West Indies. With over 3 decades of experience in the utility industry, he has expertise in generation, transmission, distribution, asset management, and human resource development. He has also served as an honorary professor at the Amity University, adjunct professor at the University of Trinidad and Tobago, and faculty at the University of Technology, Mauritius. Dr. Vishwakarma is an active member of the Institute of Engineering and Technology, UK, Engineers and Geoscientists of BC, Canada. His key area of expertise include asset management, power distribution, energy access, renewable energy, energy efficiency, energy policy, and energy conservation. Now, I request Professor Dr. Vishwakarma to kindly address the gathering with his insights on the topic of role of engineers in promoting remote patient monitoring and telehealth. Due to time constraint, we request you, sir, conclude your session within 40 minutes of time. Please, sir.
Thank you very much, young man, for the nice introduction and the warm welcome. Sorry if I was too picky, because I wanted to ensure that your audio-visual system that runs properly so that I'm able to interact. And I have been interacting with Amity students, I think for the past 4 years now. All right. And I have always tried that my session must be interactive. So it should be a two-way communication. It is not only me speaking something from here and you guys, you are listening. No, I would appreciate that you also ask questions to me. And I would in fact appreciate that first the students try to answer, the researchers try to answer, and then only the faculty member, they step in or they jump in if the students are not able to share the expected response. Can I share my screen? Uh, can you see my screen? Can you see my screen?
Yes, sir.
Are you able to see my screen?
Yes, sir.
All right. Are you still able to see the screen? Are you still able to see the screen? Yes or no?
Yes, sir.
Yes. All right. Okay. Last time in the past, what has been happening? What was happening that I was running my slides, but the slides were not rolling at your end. That was the challenge. All right. So now I'm rolling my slides and just to see, answer me that if my slides are rolling and can be seen rolling at your end or not. Is it rolling?
Yes, sir.
Is it rolling? Is it rolling? Yes or no? Yes or no? I'm not able to hear you. Yes or no?
Yes,
Yes. No, see, it is echoing a lot. It is echoing a lot. Same audio problem. Can somebody speak something? And then I will tell that, yes, your voice is, hello. Again, lot of echo. Lot of echo. I don't know what is happening. Lot of echo.
Sir, now it is fine.
Now it is fine. All right. So make sure that it remains well. All right. So thank you very much once again. And today I once again have the privilege of interacting with my Amity students, researchers, and faculty members. I have been asked to deliver a session on role of engineers in promoting remote patient monitoring and telehealth. You might think that I am an energy sector professional, and how come I have been asked to talk about remote patient monitoring and telehealth? So this can be a question and somebody must be thinking about it. All right. Okay. So maybe we can hello. Yes. Can you hear me?
Yes, sir.
All right. Okay. So at the outset, my gratitude to Dr. Balwinder Shukla, Vice Chancellor, Dr. Manoj Pandey, Director, Dr. Sanjeev Thakur, HOD, Dr. Garima Agarwal, Head International Collaboration, Dr. Neha Tyagi, and everyone in the Department of Computer Science and Engineering, Amity School of Engineering and Technology, India. Thank you once again for giving me this opportunity. As I mentioned that I have been interacting with you in the past years also. This gentleman, he has already read my biography. All right, here, without any intention of blowing my own trumpet. All right, I would just like you. Are you able to see the screen? Are you able to see the screen?
Yes, sir.
All right. Just if you can see, gentlemen, I started working as a diploma holder in electrical engineering. I was just having a diploma in electrical engineering. I was not even having a full engineering degree and no postgraduate qualification. All right, when I started working, and starting from 1988, all right, I have been continuously working till today. That means almost 38 years I have been working. And what message I want to convey to you, all right, that normally it is a thought that once we have completed, once we are out of college and once we are in the world of work, then we guys think that we have studied enough. Now there is no need to study further. And now we are working. So we don't have time. We don't have time. We don't have time here. Without any intention of blowing my own trumpet, just I would like to share with you that students, if you are determined, all right, that you can see here from 1987 when I completed my diploma, I started working, and without leaving my job for a single day, without leaving my job for a single day, all right, I just used my casual leave, my medical leave, my earned leave, that means whatever vacation that my organization was giving to me. And then from diploma, I earned, while I was working full time, I earned my bachelor degree, I earned my master degree, I earned my advanced certificate, I earned my PhD, I did my certificate course in Canada, and I did undertook postdoctoral research. All right, without leaving my job for a single day. I just want to convey that this is a sustainable approach. If you want to progress in your career, all right, just stop thinking that once you have started working, then you cannot study. This is absolutely incorrect, untrue. This is the first message I give everywhere, wherever I lecture. 2 months back, I was in India and I was invited by as many as 5 institutions. I had the privilege of visiting Amity University also. I met a few faculty members, but that time probably your examinations were going on last month, so I couldn't interact with the student. Once again, I repeat that please do not divorce your studies. Even though you have started working, continue to improve your qualification, and that gives you an utmost satisfaction. All right. So this is the agenda of my today's presentation. I will be talking about remote patient monitoring. I will be talking about telehealth. Then I will be mentioning that what are the challenges which our health professionals they are facing. Then the key thing what I'm going to talk is what is the role of policymakers and regulators, and on the top of that, what is your role, what is our role, what is my role, and what is your role of entire engineering community in promoting remote patient monitoring and telehealth. And then I will conclude with my concluding remarks. You can see on the left hand side, this entire healthcare system now it is being digitized. It is being run by artificial intelligence. It is being run by several technologies which are continually evolving every day. And just now Professor Garima told me that most of the students they are from electronics or computer or artificial intelligence. That is something very good, because this is something, basically this is your cup of tea. All right. Once again, can you see my slides rolling?
Yes, sir.
Are you able to hear me?
Yes, sir.
All right. Okay. So once again, all right, coming to this point, as I mentioned now, health sector, it is undergoing technological transformation. Even when you are seeing in India, this technology is really developing like anything. And I am proud to say that originally I belong to India. Today also I belong to India. And I can say India is not at par. In fact, India is much ahead as far as electronics, computers, artificial intelligence, or any modern technology is concerned. Indian technology is topmost. I am proud to say that. So healthcare sector worldwide is undergoing a technological transformation with artificial intelligence positioned as a central driver of change. On the left hand side, I have shown the image. That image actually is representing our nation. That how medical technology, medical electronics, biomedical engineering that is developing. And in fact, our technology is being used by other countries, even developed countries, Western countries. Our technologies are being used, and I'm proud to say, I really feel extremely proud when I see that engineers and technologists of my home country, they are working, they are holding the key positions, and they are the one who are developing the technologies, they are improving the technologies, they are implementing the technologies, and whenever there is any bottleneck, they are the one who are fixing the problem. So in the healthcare sector, right from early disease detection to personalized treatment, artificial intelligence is reshaping the way healthcare is being delivered, particularly in the rural and the underserved area. All right. The large urban hospitals now they are integrating their advanced diagnostic system, while rural communities they are gaining access to telemedicine platforms using machine learning, artificial intelligence technology. So this shift is actually narrowing the divide between world-class medical institutions and the underserved population. I once again repeat when I say underserved population because I have worked in Africa for 13 years. Luckily, I was working on a small island nation that was much developed. But when you go to interior of Africa, you will find that even as on today's date also, people are deprived of basic amenities. Basic amenities. Health is much far. Health technology has not even reached several locations, especially in sub-Saharan Africa. Poverty is still at its peak, and people are deprived of essential commodities, including health facilities. As I told you, these emerging technologies, they are revolutionizing the healthcare. These digital health technologies, they are making a significant shift towards patient empowerment and co-design in healthcare. On the right hand side, you can see that almost every part of our body, all right, the digital health landscape it has taken over. Maybe it is your arm, maybe it is your wrist, maybe it is your heart, maybe it is your face, maybe it is your cheek, maybe it is your ear, maybe it is your heart, maybe it is your wrist, maybe it is your ankle. Everywhere, all right, you can see on the right hand side there are smart shoes, there are smart socks, there are stress and fitness belt, there are pulse oximeter, there are smart patches, wireless glucose monitor, smart inhaler, smart glasses, everything. Almost your complete body, it has got electronic devices. They can take care, they can monitor the all whatever is happening inside your body. That can be remotely recorded and that can be remotely analyzed. So what exactly it is helping? It is helping to empower patients and individuals to take care of their own health using health trackers, wearables, and sensors. And they help us to know more about ourselves and retake control over our own lives. Yes, doctor will help you, but we can see by ourselves that yes, my glucose level is going high, my blood pressure is getting low, my blood pressure is increasing, my heartbeat is increasing. We can find out by ourselves, and then we can immediately take whatever action that we can take by ourselves. And then if suppose there is something which we cannot take care of, then we can always approach our doctor. That also we can approach our doctor through telehealth. That means remotely we can consult our doctor, we can talk to our physician, we can talk to our nurse, we can talk to our radiographer, we can talk to our sonographer, we can talk to our pathologist, and we can get whatever kind of treatment we need to have to be able to control ourselves. So addressing critical challenges of workforce shortages, aging population, chronic disease management, and the need for efficient and personalized care, all these challenges, they are being taken care by by the revolutionizing of the healthcare technologies. Whatever is happening nowadays, that is helping us to address these critical challenges. So this transition, it is redefining traditional patient to door dynamics, fostering collaborative partnership and driving innovation in healthcare. When I was a child, when I was in fact a student like you, that time there was no telehealth facility, no remote patient monitoring, and we had to go to the see our doctor in person. But now the situation has changed. Even here, most of the time I get telephone appointment with my doctor, or I get a virtual appointment with my doctor, and then we consult, because it is very difficult for me to leave my work and go and see to the doctor until and unless it is absolutely required. So many things, many activities now they are being undertaken virtually, and especially in the aftermath of COVID pandemic situation. Now even in India also I can see that lot of things are happening virtually. Lot of activities. There is an era of e-governance. A very strong e-governance era is there. Maybe it is rail reservation. Maybe it is appointment with your doctor. Maybe it is consultation. Maybe writing examination. Maybe evaluation. Attending classes. Anything that is being taken care of by virtually. So these technologies, these data-driven approaches, they are improving accessibility and efficiency. They are optimizing resource allocation, and they are enhancing patient outcomes. You can see this how this flow chart is working. There it is that there is the access to the healthcare, it is increasing, and what it is resulting in, it is improving patients' outcome. So what is happening? Increased efficiency. And when the efficiency increases, automatically it reduces the healthcare cost. So it is a cyclic process. All right. And these days, networked sensors, wearable devices, smart home medical devices, they are collecting real-time patient data through IoT and biometric sensors. You guys, you are studying artificial intelligence. During my time, when I studied engineering 38 years ago, that time there was no concept of artificial intelligence. Even we didn't have internet. Forget about IoT, sensors and everything. That time medical technology, it was limited to instrumentation and control. But now things are changing. Now we can timely diagnose the disease, we can make personalized treatment plans, and there is predictive health analytics that can be done by artificial intelligence and big data analytics. There are robust connectivity and processing of e-health solution by 5G and cloud computing platforms with smart digital infrastructure that is helping us a lot. Any hospital now, there is a digital access, and there is a global network. So we cannot say that I need to go to US, or I need to go to Singapore, or I need to go to India for my treatment. These days the remote consultation, telehealth, telemedicine, it has reduced the gap drastically. And it has also reduced the cost by streamlined process, optimized resource use, and focused preventive care through smart health solution. I'm going to talk about it, all right, in my coming slides. But before that, I would like to know, ladies and gentlemen, can somebody tell me that what exactly is remote patient monitoring? Can somebody tell me? You can take your mic, all right. You can take your mic around, and then maybe somebody can tell. Can somebody tell what is remote patient monitoring? Sorry?
Very good afternoon, sir.
Yes, and for me it is 11:30 p.m. my friend. It is almost midnight. But
Okay.
still you can say good afternoon, because it is good afternoon at your place. Can somebody tell me what is this remote patient monitoring?
So in simple terms, I could say monitoring any patient remotely.
Okay. Is it required?
Yes, sir. Suppose any patient is at far off place, like especially we've seen in COVID-19, where we were not allowed to move out of our houses. So there, this need arises.
Okay.
Like
Is it
after,
absolutely required?
since some scenarios, I think, yes.
All right. Can you quote some example that how does it work? Because you guys, you are students. You probably know better. If suppose somebody is monitoring you, how that is going to help you? And one more thing, even if you want to talk in Hindi, if you are not comfortable answering in English, you can answer to me in Hindi also.
Sir,
But what is it? Yeah.
the remote patient monitoring system is very useful nowadays as it's, city and so
No, your voice is breaking. Voice is breaking. I'm not able to hear you. You just give me 2 examples of remote patient monitoring, then I can proceed further.
sir, so children can monitor distance.
No, I'm not able to. You just do something. Go to the podium, and from there you talk to me.
Sir,
You just tell me. All right. You just tell me what can be monitored using remote patient monitoring. If suppose I am a patient, what all parameters you can monitor remotely?
uh, children can
Come on guys, you are electronic students, engineering students. आपका ऑडियो विजुअल सिस्टम ही कैसा है पता नहीं, समझ में नहीं आता.
sir,
ये
heart ECG.
कंटिन्यूअसली तीसरे साल एक ही चीज रिपीट हो रही है.
Excuse me, sir. Am I audible?
हाँ, now you are audible. I don't know. I'm sorry to say, my friends.
Sir, you asked for an example. So,
हाँ.
if a person is on pacemaker, so a doctor can monitor his heart conditions, whether he's sleeping at night and he faced some kind of insecurities, or maybe he can feel some palpitations or something. So the doctor can monitor it from far away, and if there is an emergency, so he can be evacuated easily.
Very good. My question was, since you are electronics engineers, you are computer engineer, how does it work? This much I know, that remote, it is a grammatical meaning that yes, if the patient is there and if there is space, but how does it happen? How does it happen? This is something I wanted to know. You are an electronics engineer. You are the one who has developed that technology. So maybe if you can tell something that using what? आप लोग तो ये सारी चीजें पढ़ रहे हैं ना, तो
We
कैसे होता है? वो बताया उन्होंने कि यस पेस मेकर इज देयर, वेरी गुड. डॉक्टर वहां बैठा हुआ है, डॉक्टर इज नॉट एन इंजीनियर. वो तो पेस मेकर में जो चीज पढ़ाई में आ रही है, वो चीज उसने सुनी और उसके बाद अपना इंटरप्रिटेशन दे दिया. बट व्हाट एग्जैक्टली इज helping or what technology is being used? What did you do? आपने as an engineer what did you do कि doctor can remotely monitor you? This is what I was asking. Remote patient monitoring, वो तो grammatical meaning तो सबको पता है. ये कैसे हो रहा है ये पूछना था, क्योंकि आप ही लोगों ने इसको बनाया है, आपके जो सीनियर्स ने बनाया है, और अब आप उसको सुधारोगे भी. Can anyone share the thoughts?
Sir, one example could be I'm wearing a smartwatch here, and what it
Yes.
does is tracking my stress rate and heart rate, sorry, and using
Very
that
good.
can figure out if my stress rate is high and accordingly help like have some diagnostics for that. One thing is if they are not using some wearable like this, okay, they are taking the diagnostics when we are going to them, but that alone won't be sufficient. We have to track across the entire day that how the changes are happening. So that might help. That is
बेटे ये कैसे हो रहा है यही तो मैं पूछ रहा हूँ. ये तो ग्रामेटिकल तो मुझे भी पता है कि इधर से अपन ने स्मार्ट वॉच पहनी, उधर से डॉक्टर ने रीडिंगली बताया, लेकिन ये कैसे आप लोगों ने कैसे किया इसको, यही
But-
तो मैं पूछना चाहता हूँ. आप लोगों ने कैसे किया? वो व्हाट इज द टेक्नोलॉजी? ये कैसे हो रहा है ये?
So
उसमें
there
क्या
are
हो क्या?
sensors,
yes?
sir, light-based sensors, which basically trace our like heart rate. Exactly, I don't remember, but
ओके ठीक है. इफ यू डोंट रिमेम्बर देन डोंट एक्सपेक्ट मी दैट आई वुड नो, बिकॉज मैंने तो 38 ईयर्स पहले इंजीनियरिंग पढ़ी थी. मैं तो यही इसी के लिए तो मैंने बोला ना कि मेरे को इंटरैक्टिव सेशन किया था. मेरा पास एक्सपीरियंस है, आपके पास फर्स्ट हैंड नॉलेज है. दिस इज व्हाट आई वांटेड टू नो. चलो ठीक है, कोई बात नहीं, आपकी बात मान लेते हैं, आगे बढ़ जाते हैं।
Sir,
यस,
sir,
हाँ बोलिए।
so for the like you told, I'm like pulse oximeter sensors or
हाँ
blood tests we can use.
हाँ,
So with the combination of this and a single IoT device we can monitor.
आपसे एक काम करिए बेटा, आप पोडियम पे चले जाइए, क्योंकि फिर आप कुछ बोल रहे हो लेकिन मैं सुन नहीं पा रहा हूँ। आप पोडियम पे जाके बोलिए, वॉट एवर यू वांट, आई विल बी एबल टू अंडरस्टैंड बेटर।
Sir, pulse oximeter.
हाँ
Then we have blood pressure cuffs.
बेटा, यही चीज तो हम आपसे पूछ रहे हैं ना, आपने इतने सारे डिवाइस के नाम बता दिए, मेरे को ये पर बता दो कि कोई भी एक डिवाइस कैसे काम कर रहा है। यही तो हम जानना, कि ये तो पता है व्हाट इज रिमोट पेशेंट मॉनिटरिंग, सबको पता है कि रिमोटली पेशेंट को अगर जो मॉनिटर किया जाता है वो तो इसका ग्रामेटिकल मतलब है। बट हाउ इज दिस हैपनिंग, कैसे हो रहा है ये? यही मैं, क्योंकि आप लोग ही ना तो ये टेक्नोलॉजी डेवलप करी है, और इसको फ्यूचर में भी डेवलप करने की जवाबदारी आप लोगों की ही है। यू आर द फ्यूचर इंजीनियर्स, यू आर द बिल्डर ऑफ टुमारोज इंडिया, है ना? ये कैसे हो रहा है? एक कोई दो टेक्नोलॉजी बता दो कैसे होती है। भाई जैसे आपने बताया ट्यूबलाइट कैसे जलती है, तो ठीक है, हमारे जमाने में तो आप इलेक्ट्रॉनिक वाले चौक, वो चौक आते नहीं थे हमारे यहाँ, तो उस समय तो बलास्ट के चौक रहते थे, फिर एक स्टार्टर रहता था, एक फ्लोरोसेंट एक ट्यूब रहती थी जिसमें एक इनर्ट गैस भरी रहती थी, फिर हम बोलते थे कि जो चौक रहता है वो बहुत हाई वोल्टेज इंस्टेंटेनियसली डेवलप करता है, तो जिससे जो ट्यूब के बीच की जो गैस रहती है वो आयनाइज हो जाती है, इतनी ज़्यादा आयनाइज़ हो जाती है कि वो कंडक्टिव हो जाती है, जिससे ट्यूबलाइट जल जाती है। ये एक टेक्निकल आंसर होता है कि ट्यूबलाइट कैसे जलती है। अगर आप बोलो कि अरे वो स्विच दबाओ तो ट्यूबलाइट जलती है, वो तो एक लेमैन भी बोल देगा कि हाँ, स्विच जलाओ तो ट्यूबलाइट जलती है। लेकिन कैसे ट्यूबलाइट जलती है, ये तो एक इंजीनियर ही बता सकता है। तो दैट इज़ व्हाट आई वाज़ आस्किंग, व्हाट इज़ रिमोट पेशेंट मॉनिटरिंग? हाउ यू आर एबल टू डू दैट? जस्ट आई वांटेड टू हियर फ्रॉम यू 2 एग्ज़ाम्पल कैसे, कि कोई भी 2 टेक्नोलॉजी बता दो कि जिससे हमारा आदमी वो पेशेंट मॉनिटर कर रहा है। वो तो सबको पता है, वो तो एक नॉन टेक्निकल आदमी भी बोल देगा कि उसने यहाँ पे घड़ी बांधी हुई है और वहां पे रीडिंग जा रही है, जिसको देख के डॉक्टर बता रहा है कि हाँ तेरा ब्लड प्रेशर ज्यादा है या कम है। वो तो एक नॉन टेक्निकल आदमी है, बट यू आर इलेक्ट्रॉनिक्स इंजीनियर, सो दिस इज व्हाट आई वाज एक्सपेक्टिंग सम आंसर फ्रॉम यू। चलिए आगे बढ़ते हैं क्योंकि समय कम है। So, what is remote patient monitoring? Actually, it is offering ways for healthcare practitioner to collect real-time information on patients' physiological conditions. It is a strategy that offers a way for clinicians to observe patients' physiological parameters remotely and to intervene if abnormalities appears. And cost saving care technology, they are allowing patient to be at home instead of costly nursing home. All right, correct. Healthcare practitioners recognize RPM as an increasingly relevant tool for patient केयर। लेकिन इसके पहले ये देखिए, ये जो लास्ट 4 स्लाइड ऑलरेडी मैं ये आपको बता चुका था कि देखिए कि यहाँ पे थ्रू आईओटी एंड बायोमेट्रिक सेंसर वी आर कलेक्टिंग रियल टाइम पेशेंट, और थ्रू डाटा एनालिटिक्स वी
Hello.
आर कलेक्ट। यस, कैन यू हेयर?
Yeah. Sir, I am audible?
या प्लीज।
Yes, sir, your screen is not visible.
योर स्क्रीन यू आर नॉट एबल टू सी?
No, no.
अरे चलिए फिर से चालू कर देते हैं। नाउ कैन यू सी?
Yes, yes, sir.
ऑल राइट, ओके। सो नाउ this is what this kind of answer I was expecting. They say, I had already written for you that networked sensor, wearable watches, smart home devices collect real-time patient data through IoT and biometric sensors. I was expecting this kind of answers कि हमारे पास biometric sensors हैं, आपके data analytics है, उसकी एक information हम लेते हैं और उसके बाद उसको analyze करते हैं, process करते हैं। ये काम आप इंजीनियर्स का है, और आप ही लोग स्मार्ट डिजिटल इंफ्रास्ट्रक्चर बनाते हैं। तो आई जस्ट वांटेड टू नो कि ये होता क्या है। आपने जैसे मैंने लिखा ना, ईएल सॉल्यूशन बाय 5G एंड क्लाउड कंप्यूटिंग प्लेटफॉर्म्स, दिस काइंड ऑफ आंसर्स आई वाज एक्सपेक्टिंग दैट वी हैव गॉट आवर 5th generation network we had got. We have cloud computing platforms. What is this cloud computing platforms? एक डॉक्टर को थोड़ी ना पता है कि क्लाउड कंप्यूटिंग क्या होता है. यू आर इलेक्ट्रॉनिक्स इंजीनियर, आपको पता है. मैं तो इलेक्ट्रिकल इंजीनियर हूँ, मेरे को उतना ज्यादा नहीं पता है, थोड़ा पता है, लेकिन ज्यादा आपको ही पता है. So this is what I wanted to listen. I wanted to I was expecting those kind of responses. ठीक है कि जो स्मार्ट हेल्थ सोल्यूशन, लेकिन स्मार्ट किसने स्मार्ट बनाया? यू गाइस, यू इलेक्ट्रॉनिक्स इंजीनियर, कंप्यूटर इंजीनियर, आपने इसको स्मार्ट बनाया है. ठीक है. All right. Now these are the examples of remote patient monitoring, like digital thermometer, smart scale, wearable sensors, and others. But what technology they are working? Can somebody tell me? मैं तो बोलता हूँ digital thermometer, लेकिन ये digital thermometer कैसे चलता है? This blood pressure cuff, it is very normal, but how does it work? ECG patches, Holter monitor, event monitor. कैन समबडी टेल मी? कार्डियोलॉजी के इक्विपमेंट है, रेस्पिरेटरी केयर है, पल्स ऑक्सीमीटर होता है, स्मार्ट स्पाइरोमीटर होता है, पीक फ्लो मीटर होता है, फीटल मॉनिटर होता है, जब बच्चे का जन्म होता है तो उसकी जानकारी. लेकिन ये कैसे होता? हाउ डज इट ऑपरेट? कैन समबडी शेयर? डायबिटीज आजकल तो एकदम घर घर, हर तीसरे घर में डायबिटीज का पेशेंट रहता है. ग्लूकोमीटर है, कंटिन्यूस ग्लूकोज मॉनिटर है. ये सब तो रिमोट पेशेंट मॉनिटरिंग होती है. कैन समबडी टेल मी? कोई एक आधी एग्जाम्पल बताओ कि ये कैसे कोई भी होल्टर मॉनिटर का बता दो या स्पाइरोमीटर बता दो, कैसे फंक्शन करता है ये. अब मैं तो हिंदी में बात कर रहा हूँ आपसे. एक आधा कोई इंस्ट्रूमेंट का बता दो, कैसे यूज करते हैं, कैसे ये ऑपरेट होता है. मुझको भी अच्छा लगेगा कि यस
Hello.
आई एम. यस यस, यहाँ बेटा बोलिए.
So for the thermometer, we said, but it has a mercury in it. So when we put it
लाइक.
under our tongue,
हाँ
any body
हाँ
part is usually warm.
हाँ.
So it
ओके, वेरी
radiates,
गुड.
and because of that, we are able to monitor how much temperature we are currently in. And it's basically like the amount is already been like measured already, that how much it can raise based on the body temperature.
बेटा डिजिटल थर्मामीटर कैसे काम करता है? ये तो आपने जो बताया है, ये तो हम लोग हमारे जमाने में मर्क्यूरी का जो थर्मामीटर रहता था ना, वो ऐसे ऑपरेट करता था. आज की तारीख में तो डिजिटल थर्मामीटर है, सब जगह ट्रांसड्यूसर्स लगे हुए हैं, इंस्ट्रूमेंटेशन कंट्रोल का जमाना है. अब वो मर्क्यूरी वाले थर्मामीटर थोड़ी ना चलते हैं, अब तो डिजिटल थर्मामीटर. एनालॉग का तो जमाना चला गया. बिजली के मीटर भी हमारे जमाने में घड़ी वाले मीटर चलते थे. हमारे जमाने में वो प्रियदर्शनी टेलीफोन मॉडल चलता था. हमारे जमाने में तो ये जो सेल फोन है, मोबाइल फोन है, इनका जन्म ही नहीं हुआ था. ये मोबाइल टेक्नोलॉजी तो पिछले 20 साल में आई है. इट इज ए यंग टेक्नोलॉजी. तो ये डिजिटल थर्मामीटर कैसे काम करता है? वियरेबल सेंसर, ये कैसे काम करते हैं? ये मैं इसलिए आपसे पूछ रहा हूँ कि आने वाली स्लाइड में मुझको आपसे यही पूछना है कि जो भविष्य के जो इंजीनियर्स हैं, जो टॉपिक भी है मेरा प्रेजेंटेशन का, इसमें आपका क्या रोल है? आपको क्या करना है? अभी अभी आज की तारीख तक क्या काम हुआ है और उस काम को आपको कैसे आगे ले जाना है?
So
यही हमको आपसे बातें करनी थी. कोई एक बताओ, डिजिटल थर्मामीटर कैसे काम करता है? उसके अंदर मर्क्यूरी रहती है क्या?
so digital में mercury नहीं रहती, but
हाँ,
it
तो फिर कैसे चलता है? हमें तो नहीं पता बेटा, बताइए ना.
So, digital thermometers have sensors in it, so infrared-based sensors and pyroelectric sensors that convert your that count that they do into electrical signals, and those electrical signals are actually accounted for, and based on that, it is calculated how much the temperature is raising. Is that it?
बहुत बढ़िया, बहुत बढ़िया. बेटा आप यू आर ए फैकल्टी मेंबर और यू आर ए स्टूडेंट?
No, sir, I'm an undergraduate student in third year.
Undergraduate student. But this kind of answer I was expecting.
Yes, sir.
Actually, this kind. Thank you very much, Betty. Very good. Thank you very much. Anybody else? अब तो ये फर्स्ट ईयर अंडर ग्रेजुएट स्टूडेंट ने बता दिया है. आप अब तो मुझे जहाँ तक बताया गया है कि आपके यहाँ एमटेक के स्कॉलर्स भी हैं. इस तरह का कुछ आंसर दो तो हमको भी अच्छा लगे, हमको भी कोई नई चीज सीखने मिले. ये स्पाइरोमीटर, ऑक्सीमीटर, ये सब क्या होते हैं? जैसे ये बिटिया ने बताया ना, ये किस तरह से एक इक्विपमेंट का बताया. एक कैन समबडी एल्स टेल मी? इतने सारे मैंने नाम लिखे हुए हैं, एक आध कुछ और बता दो, मुझको तो पता नहीं. बेटा आप ही बताइए अगर इनमें से कोई, इफ यू नो सम एनी अदर इक्विपमेंट, एनी अदर मेडिकल इलेक्ट्रॉनिक्स इक्विपमेंट that helps in remote monitoring, remote analysis of data.
Sir, as much as I know about oximeter because I've seen it in my house,
Very good.
it's based on light detectors.
हाँ,
The light, there are two types of light, a red and a green light, and on basis of that detector, it tells how much your oxygen level is going up and down.
नहीं तो यही तो मैं जानना चाहता हूँ कि लाल और हरी रंग की लाइट जलती है, तो अलग अलग सिनेरियो में क्या होता है कि लाल लाइट जलती है, हरी नहीं जलती, हरी जलती है, लाल नहीं, और कौन से सिग्नल जाते हैं और कैसे जाते हैं? क्योंकि हमको ये एक्चुअली गरिमा मैडम ने 10 मिनट का समय और दे दिया, इसलिए हमको अच्छा लग रहा है कि कुछ आप लोगों से बातें कर लें। उसके बाद नहीं तो हम एक सिरे से बोलना शुरू करेंगे, हम कुछ भी बोल के चले जाएँगे, आप लोग कुछ-कुछ सुनेंगे, जैसे ही खत्म होगा तालियाँ बजा दोगे, हम भी चले गए, आप भी चले गए, कहानी खत्म। लेकिन ना हमने कुछ आपसे सीखा, ना आपने कुछ हमसे सीखा, है ना?
Yes, sir.
हाँ, और कुछ भी जल्दी बताओ क्योंकि हमको आगे अभी बढ़ना है ना फिर। अभी आपने इतना अच्छा आंसर दिया, कोई और भी तो इतने सारे स्टूडेंट्स बैठे हैं, कोई एक आधा इक्विपमेंट के बारे में तो बताओ कि वो काम कैसे करता है? हाँ, बोलिए।
Sir, I can tell about ECG patches.
हाँ, वेरी गुड बेटे, बताइए। थोड़ा वहाँ बस पोडियम पे जाके बोलो ताकि हम अच्छे से सुन सकें।
Sir, about ECG patches, I know it has the electrodes. They are made of silver chloride, and
हाँ,
so they use the wire goes through it to an IoT device,
हाँ,
in which sir it counts the waves like P waves and T waves,
हाँ, फिर?
and sir then it process the waves across the uh, veins and in the and it's
प्रोसेसर कहाँ रहता है? प्रोसेसर क्या उसी में लगा रहता है या प्रोसेसर कहीं और रहता है?
सर अलग से
आपने
रहता है।
बोला ना प्रोसेस करते हैं, तो कहाँ रहता है प्रोसेसर?
Uh,
उसी में रहता है?
that it is connected, the electrodes are connected to a single device, the IoT.
हाँ, वेरी गुड।
Yeah,
नहीं
so
तो उसका मदरबोर्ड कहाँ रहता है? डाटा कहाँ कलेक्ट हो रहा है? डाटा कहाँ एनालाइज़ होता है? उसी जगह होता है, दूसरी जगह होता है?
uh, हाँ सर आई नहीं लोकेशन पूछ रहा हूँ, उसी में रहता है बाहर रहता है डिवाइस।
क्योंकि बात चल रही है रिमोट पेशेंट मॉनिटरिंग की, तो आपके जैसे मान लीजिए मैं बीमार हूँ और मैं आपके घर में मेरा इलाज चल रहा है, आपने ये जो आपने बोला ना ऑक्सीमीटर, चलो आपने लगा दिया कि विश्वकर्मा जी की जो ऑक्सीजन है ऊपर नीचे हो रही है, उसमें कब इनको ऑक्सीजन देना है, कब नहीं देना है, ठीक है? तो ये वहाँ पे सेंस तो आपने कर लिया, लेकिन ये जो इंफॉर्मेशन सेंस कर रहा है करी गई है, ये कहाँ पे एनालाइज हो रही है और कहाँ से इसके सिग्नल्स जनरेट हो रहे हैं कि हाँ, अब इनका ऑक्सीजन लेवल बढ़ाओ या इनका ऑक्सीजन लेवल कम करो। ये कौन कर रहा है? कहाँ पे हो रहा है ये काम?
In ECG there are three levels. Uh,
हाँ,
First is in the
अभी
node
तो आप ऑक्सीमीटर की बात कर रहे थे, तो ईसीजी वाली बात कहाँ से आ गई? अभी तो
process.
अपन ऑक्सीमीटर की बात कर रहे थे ना।
Sir, it was other student. I was talking about ECG passage.
अच्छा, चलो वो बता दो, चलो कुछ तो बताओ यार। हाँ।
In ECG patches there are three levels. The first
हम्म,
is from the node it goes to first in the node itself. It amplifies the signal. Then it using the T and P waves. Then
हाँ,
then it process to you can say gateway, external
हम्म,
gateway. It could be a, computer or a smartphone, where the signal smoothing and ECG wave plotting is done. And
ये सारा जो कुछ भी होता है इसके लिए क्या कोई एल्गोरिथम लिखी जाती है क्या? एल्गोरिथम लिखी जाती है क्या इसके लिए कि भाई ये मतलब किसको पता है कि कौन से स्टेप पे आके क्या होना है? कोई तो एल्गोरिथम लिखता है या कौन प्रोग्रामिंग कौन करता है? आप ही लोग करते हैं?
Sir, IoT systems are mainly based on embedded systems. So embedded
वेरी गुड, वेरी
working
गुड बेटे।
program it on a microcontroller. Basically, the microcontroller पे programs लिखे जाते हैं according to our requirement, and on basis of that programs, the whole system works.
अच्छा, अच्छा, वेरी गुड, वेरी गुड। तो ये जो आपने जितनी भी बातें बताई हैं, ये क्या वो जो इक्विपमेंट है उसी के अंदर ये टेक्नोलॉजी एम्बेडेड रहती है, या इसका मदरबोर्ड कहीं और रहता है, या इसका जो वो जो मॉनिटरिंग या जो कंट्रोल डिवाइस है कहीं और रहता है, यहाँ पर केवल सेंसर रहता है? हैं?
Goes to the cloud at the end.
अच्छा, क्लाउड एंड पे रहता है। मतलब अस्पताल में डाटा एनालाइज नहीं होता, वो यहीं ऑक्सीमीटर या ईसीजी जहाँ लगा है वहीं के वहीं एनालाइज होके इंफॉर्मेशन वहाँ चली जाती है, ऐसा कुछ है क्या?
सर IoT systems में तीन phases होते हैं. First is your sensors. Sensors are basically induced in your wearable devices. तो
वेरी गुड।
वहाँ पे जो basic immediate data है, it is stored in cache, and then through the network that on which the IoT device is connected on, that cache data is transferred to the cloud network, and
हाँ, वेरी गुड।
the data that is collected in the cloud network, now the processing is done, and after that the result is again transferred to your device.
हाँ, तो वही तो मैं पूछ रहा हूँ, जो डाटा प्रोसेस हो रहा है वो कहाँ पे हो रहा है? क्लाउड से तो आपने डाटा उठाया, प्रोसेसर कहाँ लगा है?
So the processor is on the device only. That's how it's.
डिवाइस पे ही लगा है, अच्छा। मतलब
That's
केवल 2 जगह के बीच में कम्युनिकेशन होता है, डिवाइस और क्लाउड के बीच में, और उसमें कोई थर्ड पार्टी इन्वॉल्व नहीं है।
there is obviously the server जहाँ पे हम
हाँ, सर्वर कहाँ है? कहाँ है सर्वर?
so in case of a remote patient monitoring system, it must be your doctor or the hospital facility.
हाँ, ये बस यही तो पूछना था कि ये 3 इसकी जो फंक्शनैलिटी है, ये 3 जगह इनकी यूनिट रहती है। एक जगह सेंसर रहता है, एक
Yes,
हॉस्पिटल में इसका प्रोसेसर रहता है, और जो क्लाउड में इसका स्टोरेज रहता है। यही
yes,
तो हम पूछ रहे थे।
yes, sir.
चलो, चलो कितनी मेहनत करनी करनी पड़ी विश्वकर्मा जी को अपने काम की चीज पता करने के लिए। और जो मैं कहना हूँ कि इन्फॉर्मेशन सब आपके पास है, बट यू गाइस यू आर सो हेजिटेंट। आप बताने के लिए हिम्मत नहीं कर पाते हो, झिझक आपके अंदर इतनी है कि ये लगता है कि हम गलत ना बता दें।
Yes, sir.
ये चीज मैंने ना अपने जब इंडिया में बच्चों को जब मैं इंटरेक्ट करता हूँ तो ये चीज मैंने महसूस करी है। जबकि यही जब आप यूएस, कनाडा या इंग्लैंड के बच्चों के साथ इंटरेक्ट करते हो, वो लोग तुरंत इंस्टेंट रिस्पॉन्ड करते हैं। गलत ही कर देंगे लेकिन कहते हैं एज फार एज आई थिंक दिस इज व्हाट दैट हैपेंस। वो जो झिझक उनके यहाँ नहीं है और मेरे बच्चों में जो है, इसी के कारण थोड़ी गड़बड़ी हो जाती है। इसी के लिए अभी मैं 2 महीने पहले इंडिया में ही था। मैं 5 यूनिवर्सिटीज में गया, आईआईटीज में भी गया, बच्चों से बात करी, उनको मालूम रहता है जब तक हम खुद खुरेदे नहीं, जैसे पुलिस वाला नहीं उगलवाता
Yes, sir.
है ना? उस तरह से आप लोगों से कितनी मशक्कत करनी पड़ी। आंसर तो आपके पास से निकल ही गया, वो आपने बताया ही नहीं, कितनी मेहनत करनी पड़ी, है ना? तब बताया, बट यू न्यू द आंसर।
Yes.
चलो एनीवे, थैंक यू वेरी मच बेटे। बिटिया आपको भी थैंक यू। ओके, सो नाउ दिस रिमोट पेशेंट मॉनिटरिंग दिस इज बीइंग यूज्ड वर्ल्ड वाइड। हम कनाडा में रहते हैं, जहाँ पर हम ब्रिटिश कोलंबिया में रहते हैं, तो हम जिस एरिया में रहते हैं वो फ्रेजर वैली कहलाता है। तो हमारे यहाँ जो हेल्थ अथॉरिटी है दैट इज कॉल्ड फ्रेजर हेल्थ अथॉरिटी। दे आर हैविंग, देखो लेफ्ट हैंड साइड में लिखा है ना, रिमोट पेशेंट मॉनिटरिंग। केयर टीम्स वर्चुअली मॉनिटर योर हेल्थ कंडीशन व्हाइल यू आर एट होम। ठीक है। और यहाँ पर अब ये थाईलैंड की बात हो रही है। थाईलैंड लॉन्चेस केयर कैमरा फॉर रिमोट पेशेंट केयर। सैस्कैटचुअन, ये मैं ब्रिटिश कोलंबिया प्रोविंस में रहता हूँ, तो और सैस्कैटचुअन जो है ये हमारा नेबरिंग प्रोविंस है। यहाँ पर भी रिमोट पेशेंट मॉनिटरिंग इज एन इंटरैक्टिव वर्चुअल क्लिनिशियन पेशेंट प्लेटफॉर्म दैट एनेबल्स पेशेंट इंफॉर्मेशन इलेक्ट्रॉनिकली विद देयर प्रोवाइडर। ये यूनाइटेड अरब एमिरेट्स का है, जो मिनिस्ट्री ऑफ हेल्थ that unveils a smart application of AI based remote patient monitoring। तो जो मैं कहना चाहता हूँ, वर्ल्ड वाइड ये काम हो रहा है। इंग्लैंड में जो नेशनल हेल्थ सर्विसेज है इंग्लैंड, दे आर सपोर्टिंग केयर विद रिमोट मॉनिटरिंग। ऑस्ट्रेलिया में देखिए, रिमोट पेशेंट मॉनिटरिंग इज ए सिस्टम दैट अलाउज हेल्थ केयर प्रोफेशनल टू असेस, मॉनिटर एंड केयर फॉर पेशेंट वर्चुअली। यहाँ पर बेटा जो सबसे ज्यादा की रोल है वो आप लोगों का है, क्योंकि दे आर यूजर्स। जो हेल्थ केयर प्रोफेशनल्स है ना, दे आर यूजर ऑफ योर प्रोडक्ट। प्रोडक्ट तो आप बना रहे हो, टेक्नोलॉजी आप बना रहे हो, सॉफ्टवेयर आप लिख रहे हो, एल्गोरिथम आप लिख रहे हो, वो लोग तो केवल यूज कर रहे हैं। तो आप लोग क्या बना रहे हो और उसको और कितनी तरह से अच्छा बनाया जा सकता है, और और क्या क्या बनाया जा सकता है जिससे हमारे मरीजों को फायदा हो। ये मेरे और आपके जो इंजीनियरिंग कम्युनिटी है, ये हमारी रिस्पॉन्सिबिलिटी है। उसी के बारे में हम आज आपसे बात करने के लिए आए हैं। ठीक है। अब टेली हेल्थ की बात आ रही है। ये टेली हेल्थ क्या होता है? क्या ये आरपीएन रिमोट पेशेंट मॉनिटरिंग से डिफरेंट होता है क्या? ये टेली हेल्थ का कभी आपने नाम सुना है क्या? हैं? सुना है बेटा? हेलो,
हाँ सर।
ये टेली हेल्थ क्या होता है यार? मुझे मालूम नहीं
So what from the I can understood is
है।
that
हाँ,
So, telehealth is basically when we are using this facility जब हमने सारे data collect कर लिए हैं and now the patient wants to connect with the doctor on a personal level, so we are using facilities like video calls and messages and other conferencing devices. तो basically यही होना चाहिए telehealth in my knowledge.
अच्छा बेटा, ये क्या आरपीएम रिमोट पेशेंट मॉनिटरिंग से फर्क होता है क्या? ये अलग है क्या कोई चीज? ये इनमें आपस में कोई इज देयर एनी रिलेशन, या दोनों एकदम अलग अलग है?
Sir, I think they are adjacent because remote patient monitorings are basically the technologies that are being used, and telehealth is also in itself a technology, but that is being used to connect to the patient on a verbal level and maybe convey the data that is connected in a manner that the patient can understand better. Because of
अच्छा अच्छा बेटा, क्या मैं ऐसा कह सकता हूँ कि टेली हेल्थ इज ए सबसेट ऑफ रिमोट पेशेंट मॉनिटरिंग, या वाइस वर्सा? क्या मैं ऐसा बोल सकता हूँ कि रिमोट पेशेंट मॉनिटरिंग इज ए सबसेट ऑफ टेली हेल्थ? मैं ऐसा बोल सकता हूँ क्या?
yes sir.
क्या कौन सा स्टेटमेंट सही है?
So you can say sir telehealth is a subset of RPM.
अच्छा, अब आप बोल रहे हैं टेली हेल्थ इज ए सबसेट ऑफ आरपीएम।
Yes
और
sir.
कोई आंसर? और कोई आंसर? ऐसा तो नहीं कि इसका उल्टा है? मुझे नहीं पता, इसलिए आपसे पूछ रहा हूँ।
Whether in RPM we are doing continuous monitoring, right?
हाँ,
And in telehealth, what from the word and explanation I've understood is it is like human interference in that, understanding the situation in consulting way.
मतलब टेली हेल्थ सीधे सीधे रिमोट पेशेंट मॉनिटरिंग का एक हिस्सा है,
Yes sir. In which
हिंदी में जिसको बोलते हैं। चलिए, आपकी बात मान लेते हैं भाई साहब, देखते हैं आगे क्या लिखा है। So telehealth, actually telehealth is the use of digital information and communication technologies to access healthcare services remotely and manage our health. जरा ध्यान से सुनिए, use of digital information and communication technologies to access healthcare services and manage our health. So, use of technology to deliver healthcare services remotely, allowing patients and providers to connect when they are geographically separated. That is actually telehealth services. Technologies can include computer and mobile devices such as tablets and smartphone, जिससे हमारा डॉक्टर के साथ संपर्क हो जाए। देखिए, इंडिया में आजकल जो ई संजीवनी जो योजना चली है ना, उसमें this sandbox telemedicine service of India is a step towards digital health equity to achieve universal health coverage. eSanjeevani facilitates quick and easy access to doctors and medical specialists from your smartphone. You can also access quality health services remotely via eSanjeevani by visiting the nearest Ayushman Bharat Health and Wellness Services. ठीक है? इसमें कहीं पर भी मॉनिटरिंग की तो बात आई ही नहीं है टेली हेल्थ में। टेली हेल्थ तो ये बोलता है कि आप सर्विसेज वो कर सकते हैं। अब देखिए, यहाँ पे लिखा है इंक्लूड्स वर्चुअल डॉक्टर विजिट्स वाया वीडियो कॉन्फ्रेंस, रिमोट पेशेंट मॉनिटरिंग एंड हेल्थ रिलेटेड एजुकेशन। तो बेटा, वो जो आपने बोला था ना, ये एक्चुअली उसका उल्टा है। एक्चुअली रिमोट पेशेंट मॉनिटरिंग इज ए सबसेट ऑफ टेली हेल्थ। टेली हेल्थ एक अम्ब्रेला है जिसमें एक हिस्सा रिमोट पेशेंट मॉनिटरिंग है, बाकी इसमें हेल्थ रिलेटेड एजुकेशन भी टेली हेल्थ है। जरूरी थोड़ी ना कि आप बीमार हो गए तभी हम आपको आपके स्वास्थ्य के बारे में बता सकते हैं। हम तो जब आप अच्छे भले चंगे हैं तब भी डॉक्टर आपको सलाह देता रहता है कि देखिए, बारिश हो रही है तो बाहर जो है छाता लेके निकलो, बहुत ज्यादा ठंड हो रही है गर्म कपड़े पहन के। अगे अभी तक आपको कुछ नहीं हुआ है, एकदम से बाहर से आओ, गर्मी में लू से आओ तो तुरंत ठंडा पानी मत पियो, लू लग जाएगी। तो ये क्या हो रहा है? हेल्थ रिलेटेड एजुकेशन दिया जा रहा है। ये आपको तब दिया जाता है जब आप बीमार नहीं हो, लेकिन ये एजुकेशन देने से ये वो डॉक्टर सुनिश्चित करने की कोशिश करता है, ये हेल्थ अथॉरिटी, कि आप बीमार ना पड़ पाएँ। जब कोविड हुआ था तो कितना एजुकेशन दिया जा रहा था, मास्क लगाओ, 6 फुट की दूरी रखो, हाथ धो के करो सब कुछ काम, ये ना? तो तब भले ही किसी को कोरोना था या नहीं था, लेकिन एजुकेशन तो दी जा रही थी और डॉक्टर और दूसरी एजेंसीज़ वीडियो पर आपको एजुकेट कर रहे थे कि अगर ऐसा हो जाए तो ऐसा करो, है ना? लेकिन जब कोई एक्चुअली कोई अस्पताल में भर्ती हो या कोई बीमार है और घर पे रह के उसका इलाज हो रहा है और उसकी मॉनिटरिंग हो रही है, दैट इज कॉल्ड रिमोट पेशेंट मॉनिटरिंग। ऑल राइट। So telehealth actually allows convenient and accessible care for individuals in remote areas or those with mobility issues. ये telehealth आजकल दुनिया भर में हो रही है। फिर से देखो फ्रेजर हेल्थ, ये जहाँ हम रहते हैं, इट इज अ फ्रेजर हेल्थ वर्चुअल केयर, ए कन्वीनियंट पाथ टू केयर। ठीक है, यहाँ पे यूके में टेलाडॉक हेल्थ यूके, द ग्लोबल लीडर फॉर होलिस्टिक वर्चुअल हेल्थ एंड वेलबींग सॉल्यूशन। यहाँ पर आप ये राइट हैंड साइड में देखिए, यहाँ पर भी एक टेलेस हेल्थ, जो हमारा टेलेस है, ये सबसे बड़ा टेलीकॉम सर्विस प्रोवाइडर है। यहाँ पे जैसे इंडिया में एयरटेल है, रिलायंस है, जियो है, तो टेलेस हमारे एक टेलीकॉम सर्विस प्रोवाइडर है। तो उसने भी हेल्थ केयर में वेंचर करा है। ये एक टेलीफोन कंपनी है। और ये लोग क्या है, यू सी ए डॉक्टर, साइकोलॉजिस्ट, काउंसलर और डाइटिशियन फ्रॉम योर फोन एट योर कन्वीनियंस। इट इज अ पार्ट ऑफ अवर मिशन टू इम्प्रूव कैनेडियंस एक्सेस टू हेल्थ केयर। ये एक टेलीकम्युनिकेशन कंपनी है। ऐसे यूएई में जो मिनिस्ट्री ऑफ हेल्थ है, दैट हैज दे हैव इंट्रोड्यूस्ड एडिशनल टेलीमेडिसिन सर्विस टू वर्चुअल डॉक्टर प्लेटफॉर्म। ओंटारियो में 811 लगा है, फ्री ए सिक्योर कॉन्फिडेंशियल सर्विस यू कैन कॉल और एक्सेस 24 आवर्स ए डे। ठीक है, तो फिर से उस बात पे आए कि आरपीएम टेली हेल्थ, रिमोट पेशेंट मॉनिटरिंग इज एन इम्पॉर्टेंट सबसेट ऑफ टेली हेल्थ। जो आपने बोला था ना, वो एग्जैक्टली उसका उल्टा बोला था। ये देखिए, रिमोट पेशेंट मॉनिटरिंग वर्सेस टेली हेल्थ में क्या फर्क है। रिमोट पेशेंट मॉनिटरिंग में कंटिन्यूअस डाटा कलेक्शन एंड ट्रैकिंग ऑफ हेल्थ मैट्रिक्स होता है, जबकि टेली हेल्थ में वर्चुअल कंसल्टेशन विद हेल्थ केयर प्रोवाइडर्स होता है। रिमोट पेशेंट मॉनिटरिंग में क्रोनिक डिजीज मैनेजमेंट होता है, पोस्ट सर्जरी मॉनिटरिंग होती है एंड 24/7 ट्रैकिंग होती है, जबकि टेली हेल्थ में आपके रूटीन चेकअप और माइनस इलनेस की थेरेपी होती है रिमोटली। ठीक है, और ज़रूरत पड़ता है तो डॉक्टर कहता है नहीं आप इन पर्सन आओ, हमको आपको इन पर्सन देखना पड़ेगा। तो टेली हेल्थ इज अ ब्रॉड कैटेगरी ऑफ यूजिंग टेक्नोलॉजी टू प्रोवाइड हेल्थ केयर रिमोटली, व्हाइल रिमोट पेशेंट मॉनिटरिंग इज ए स्पेसिफिक टाइप ऑफ टेली हेल्थ। ठीक है, आरपीएम जो है, दैट यूजेस टेक्नोलॉजी ऑफन वियरेबल डिवाइसेस टू मॉनिटर पेशेंट आउटसाइड ऑफ क्लिनिकल टाइमिंग। लेकिन टेली हेल्थ जो है, दैट यूजेस टेलीकम्युनिकेशन एंड इंफॉर्मेशन टेक्नोलॉजी टू प्रोवाइड एक्सेस टू हेल्थ असेसमेंट, डायग्नोसिस, इंटरवेंशन, कंसल्टेशन, सुपरविजन एंड इंफॉर्मेशन। मैं पूरा नहीं पढ़ूंगा क्योंकि आपकी गरिमा मैडम के पास मेरा प्रेजेंटेशन है। So telehealth focuses more on the patient and provider communication to receive treatment efficiently, whereas remote patient monitoring allows them to monitor the health condition and offer an improved health condition। ये देखिए, ये रिमोट पेशेंट मॉनिटरिंग और टेली हेल्थ में आपका दूर से आपका स्वास्थ्य ठीक ठाक बना रहे, और रिमोट पेशेंट मॉनिटरिंग में जब आपको कोई रोग हो या आपके अंदर कोई किसी तरह की प्रॉब्लम हो, कोई इरेगुलरिटी हो, तो उसको कैसे मॉनिटर किया जाता है, दैट इज रिमोट पेशेंट मॉनिटरिंग। अब इसमें चैलेंजेस, क्योंकि समय खत्म हो रहा है, आर देयर चैलेंजेस इन यूजिंग आरपीएम एंड टेली हेल्थ। तो पहले बात करते हैं कि जो हेल्थ केयर प्रैक्टिशनर है वो क्या बोलते हैं। वो बोलते हैं कि इंक्रीज वर्कलोड ड्यू टू लार्ज अमाउंट ऑफ पेशेंट डाटा। ये बात तो एकदम सही है। आप लोगों ने इतना सारा डाटा दे दिया है तो जो हेल्थ केयर वर्कर है वो तो पागल हो जाएगा भाई, 8 घंटे में कितना काम करेगा। और अब जब एक बात ये है ना, अगर जो कांस्टेंट डिजीज रिमाइंडर आते रहते हैं ना, तो वो पेशेंट की घबराहट बढ़ा देता है। दूर जान तो अपन को ही फोन पे लगातार कोई चीज का एसएमएस आ रहा है, अरे 3 दिन बचे, अरे 2 दिन बचे, जरा 1 दिन बचा, अरे 12 घंटे बचे, अरे यार पता तो है, हमने तो तैयारी करके रखी है। हर थोड़ी देर में आप फोन करें कि अरे ऑफिस जाना है, ऑफिस जाना है। वो तो हमको महीने भर पहले से पता है कि ऑफिस जाना है। लेकिन जब बहुत ज्यादा रिमाइंडर आते हैं और खासकर जब बीमारी के आते हैं ना, तो आदमी, और खासकर जो ज्यादा उम्र का होता है, वो घबरा जाता है कि भाई ये सब क्या हो रहा है। टेक्निकल जो इश्यू है, जो आप लोगों ने एल्गोरिथम बताई है, कभी-कभी वो एक्यूरेट नहीं होती है, और जो आपकी टेक्नोलॉजी है उस पे ज़्यादा भरोसा नहीं कर पाता है, तो आदमी और घबरा जाता है, ये हेल्थ केयर प्रैक्टिशनर, क्योंकि वो तो इंजीनियर नहीं है आपकी तरह, और उनको मरीज को सैटिस्फाई करना है। मरीज कभी इंजीनियर के पास नहीं आएगा कि तूने कैसी मशीन बनाई। मरीज डॉक्टर को पकड़ेगा कि डॉक्टर साहब आपने कौन-सी मशीन लगाई, ये तो सही जानकारी दे ही नहीं रही है। तो वो इंजीनियर के पास नहीं जाएगा, और डॉक्टर ये नहीं कह सकता कि अरे वो तो एमिटी कॉलेज के इंजीनियरों ने बनाई थी, मैं क्या करूँ इसमें जैसा रिजल्ट आया। वो नहीं बोल सकता डॉक्टर, डॉक्टर के ऊपर जवाबदारी होती है. And many patients are elderly and technology sometimes can be disorienting. Ensure patient engagement and adherence to wearable usage. No consensus on financial responsibility. ये तो खैर आपका विषय नहीं है. प्राइवेसी एंड सिक्योरिटी कंसर्न, ये जरूर आप लोगों की जवाबदारी है कि डाटा का एन्क्रिप्शन ऐसा हो कि कोई डाटा चुरा ना सके. भाई मैं नहीं चाहता कि अमेठी कॉलेज के 3 बच्चों को कैंसर है, हम क्यों बताएं, या फला कॉलेज के किसी बच्चों को ऐसी बीमारी है घातक जो कि जिससे उसका जीवन खतरे में, हम तो ऐसा करके डिमोरलाइज कर दें. ये डॉक्टर को, जब डॉक्टर एडमिशन लेता है तो उसको एक कसम दिलवाई जाती है, ओथ लेता है कि हम पेशेंट की जानकारी कभी भी अनवांटेड एजेंसी को नहीं देंगे, नहीं तो उसकी सोशल रेपुटेशन खराब हो जाएगी. तो ये प्राइवेसी एंड सिक्योरिटी जो है ना, ये आपके तो सब डिजिटाइजेशन है, इलेक्ट्रॉनिक डाटा है, उसकी डाटा की सिक्योरिटी करना तो आप लोगों की जवाबदारी है. साइबर सिक्योरिटी की रिस्पॉन्सिबिलिटी आपकी होती है, डॉक्टर की थोड़ी ना होती है. तो ये सारे चैलेंजेस हैं, ठीक है. और ये टेली हेल्थ के क्या चैलेंजेस हैं? टेली हेल्थ के चैलेंजेस हैं दैट नॉट ऑल कैटेगरीज ऑफ सिटीजन हैव सफिशिएंट टेक्निकल इक्विपमेंट फॉर टेली मेडिसिन कंसल्टेशन. आप एकदम खूब अंदर रूरल एरिया में चले जाओ, उनको तो टेली मोबाइल फोन क्या होता है नहीं पता, उनको इंटरनेट क्या होता है नहीं पता, कंप्यूटर क्या होता है नहीं पता, वो बेचारे कैसे इलाज करवाएंगे? Licensing and regulatory challenges for provider. Many insurance company limit coverage of telehealth services or reimburse them at lower rate. ये तो नॉन टेक्निकल इशू, मैंने लाल रंग से जो हाईलाइट किया है वो आप लोगों की रिस्पॉन्सिबिलिटी है. इंटीग्रेटिंग टेलीमेडिसिन विद इलेक्ट्रॉनिक मेडिकल सिस्टम इज टफ, ये आपको सुधारना है. डाटा प्राइवेसी एंड सिक्योरिटी कंसर्न, वल्नरेबिलिटी टू हैकिंग, लीक्स और अनऑथराइज्ड एक्सेस, ये आपके लिए रिस्पॉन्सिबिलिटी है. दिस इज समथिंग यू आर एक्सपेक्टेड टू डू, ठीक है. सो आर देयर सॉल्यूशंस और चैलेंजेस इन यूजिंग आरपीएम एंड टेली हेल्थ? हाँ, रेगुलेटर्स की जवाबदारी क्या है? एक्सपेंडिंग इंटरस्टेट लाइसेंसर एग्रीमेंट फॉर फिजिशियन. ऐसा नहीं कि एक आदमी राजस्थान में, एक डॉक्टर राजस्थान में प्रैक्टिस करता है तो वो उत्तर प्रदेश में नहीं कर सकता, अगर उत्तराखंड में कर रहा है तो मध्य प्रदेश में नहीं कर सकता. वो सब रेगुलेटर्स को देखना है, इंजीनियर्स को नहीं देखना है. इंजीनियर्स को क्या देखना है, मैंने हाईलाइट कर दिया है लाल कलर में. ट्रेनिंग स्पेशलिस्ट प्रैक्टिशनर्स टू यूज टेली हेल्थ सिस्टम. Telehealth services have end-to-end data protection, multi-factor authentication, intrusion detection system and regular security audit. ये आप लोग की जवाबदारी है. टेलीफोन काउंसलिंग फॉर पेशेंट विदाउट कंप्यूटर और नो एक्सेस टू इंटरनेट, ये आपको करना है. बाकी जो काले रंग में है ये तो नॉन टेक्निकल या रेगुलेटर्स या पॉलिसी मेकर की जवाबदारी है. मैंने जो लाल रंग से हाईलाइट किया है ये आपकी जवाबदारी है, इंजीनियर्स की. यही चीज मैंने आगे जाके इसमें बताई है कि व्हाट इज द रोल ऑफ इंजीनियर्स इन प्रमोटिंग आरपीएम एंड टेली हेल्थ, जो कि विच इज द टॉपिक ऑफ माय टुडेस keynote session. As I have written that the future of healthcare lies in working hand in hand with the technology, मतलब आप लोगों के साथ एकदम हाथ से हाथ में लाके काम करना है. Engineers are expected to embrace digital technology in healthcare to create sustainable system, equalize doctor-patient relationship and find more effective solutions. ठीक है. Despite notable advancement, challenges such as data security, patient trust and interoperability remains barrier to widespread adoption. ये भी आपकी जवाबदारी है इंजीनियर्स की. And you are expected to tailor remote monitoring to provide equitable care for elderly patients, rural communities and those with limited mobility. साथ ही लो एंड मीडियम इनकम कंट्रीज दे फेस सिग्निफिकेंट बैरियर्स टू वाइडस्प्रेड आरपी रिमोट पेशेंट मॉनिटरिंग adoption, including inadequate digital infrastructure and limited financial resources for healthcare technology. You engineers, you are expected to resolve it, fix it. आपको सस्ती टेक्नोलॉजी लेके आना है. And engineers, you have an opportunity to foster a resilient, secure, inclusive and preventive healthcare system. मैंने बोला जैसे शुरू में, आने वाले देश के, आने वाले इस समाज की जवाबदारी आपकी है. आपको इस पेशे में रहना है, इंजीनियरिंग के पेशे में, और आपकी जवाबदारी है कि आपको कम्युनिटी डेवलपमेंट करना है. तो ये मत सोचो कि हमारी तनख्वाह आ गई मेरी जेब में तो मेरी जवाबदारी खत्म. नहीं, आपको इस देश को पूरे को लेके जाना है आगे, इसको प्लेनेट को पूरा आके लेके जाना है. इंजीनियर्स का किसी भी सिस्टम के डेवलपमेंट में इंजीनियर्स का बहुत बड़ा की रोल रहता है. आप एकेडमिया जैसे अमेठी यूनिवर्सिटी है, मैं आपको यहाँ पे एग्जांपल दे रहा हूँ. ये मैं जहाँ कनाडा में रहता हूँ, ये ओटावा यूनिवर्सिटी ऑफ
सॉरी टू इंटरप्ट.
मास्टर यूनिवर्सिटी, कार्लेटन यूनिवर्सिटी. हाँ, हेलो, यस बोलिए.
Sir, due to time,
Yes.
could you please
हाँ,
wrap it?
हाँ, हाँ, बस खत्म हो गया। लास्ट स्लाइड, लास्ट स्लाइड। मैं बता रहा हूँ, देखिए इतनी सारी यूनिवर्सिटी में ये सारे कॉलेज, ये कोर्सेज चल रहे हैं, ठीक है? आप भी अपने अमेठी यूनिवर्सिटी में अपने ये मैनेजमेंट को बोल सकते हो कि सर हमारे यहाँ भी कोई सुपर स्पेशलाइजेशन कोर्स लगाइए। देखिए कोलैबोरेटिव मास्टर्स ऑफ इंजीनियरिंग प्रोग्राम इन हेल्थ टेक्नोलॉजी, यहाँ बायोमेडिकल इंजीनियरिंग टेक्नोलॉजीज डिजाइन टू यूज आउटसाइड ऑफ हॉस्पिटल एंड हेल्थ केयर सेटिंग्स सो इंडिविजुअल्स कैन मॉनिटर देयर हेल्थ। ठीक है, ये है फाइनल नोट लाल रंग में। वही चीज मैं बार बार बोलते जा रहा हूँ कि ऑडियो वीडियो टेक्नोलॉजी आपको सुधारना है। एडवर्स इम्पैक्ट ऑफ इफेक्टिवनेस ऑफ दिस सिस्टम इंक्लूडिंग टेक्नोलॉजिकली आपको सुधारना है। इंजीनियर मस्ट प्ले ए सिग्निफिकेंट रोल टू एडवांस आरपीएम एंड टेलीहेल्थ बाय फोकसिंग ऑन इम्प्रूविंग डिवाइस इंटरऑपरेबिलिटी, एनहांसिंग यूजर सेंटर डिजाइन, एआई और सब कुछ। दैट्स इट, थैंक यू वेरी मच। क्वेश्चन आंसर का टाइम इसलिए हम नहीं बोल रहे क्योंकि हम तो पूरे समय आप लोगों से ही सवाल जवाब करते रहे, तो सवाल तो सारे पूरे हो ही गए हैं। और कुछ अगर आपको पूछना हो तो बताओ, टाइम भी पूरा हो गया, हमको बोल दिया गया है कि अब आप बंद करो। एनीथिंग एल्स यू वांट टू आस्क, यू कैन ऑलवेज रीच आउट टू मी। गरिमा मैडम के पास, नेहा मैडम के पास मेरा वो है, ईमेल आईडी है, आप कैन ऑलवेज सेंड योर क्वेश्चंस टू मी एंड आई विल मोर देन हैप्पी। मुझे उम्मीद है कि मैंने आप लोगों को ज्यादा परेशान नहीं किया सवाल पूछ पूछ के।
No, not at all, sir. Thank you so much, sir, for your insight, especially guidance on not to divorce our studies throughout our life, awareness on life situation and healthcare situation in India, and technological development such as health tracker, addressing challenges through IoT. Thank you so much, sir. Now, may Shubh sir, could you please,
हाँ जी,
thank
यू
you, sir.
सेड समथिंग।
Thank you, sir. Thank you so much.
ओके, ऑल राइट।
Thank you for your powerful insight on your topic role of engineers in promoting remote patient monitoring in telehealth. So I particularly appreciated your point about which this is a virtual Tulsi sapling for you as a token of gratitude or respect, or you can say from India, it's a love for you. When person you will come as a in-person Tulsi sapling.
ऑल राइट, थैंक यू वेरी मच।
Thank you, sir.
Okay, it is past midnight here. Let me go to sleep because tomorrow I have to go and I have to work.
Okay, good night, sir. Good night.
ठीक है, all right.
Thank you.
Dr. Brown. Brown is coming. Bugli. चलिए. यहीं पे भी आएगा हाँ
Good afternoon, everyone. Can you hear me?
Sir.
Great.
Now let's begin with this informative session. It's our great privilege and honor to have among us Professor Dr. G.J. Brown, University of Sheffield, UK. Dr. Brown received his BSc Honours in Applied Science from Sheffield City Polytechnic and PhD in Computer Science from the University of Sheffield. He has been with the University of Sheffield since 1992 and was appointed Professor of Computer Science in 2013, serving as head of the department from 2015 to 2023. His primary research focus is CASA, computational auditory scene analysis, aiming to model human auditory perception in complex sound environment. His work spans noise-robust speech recognition, binaural modeling, hearing impairment, and overlapping speech, with recent application in sleep monitoring and mobile robotics. He has led and co-led numerous UK, EU, and industrial funded projects, and is a co-editor of seminal book CASA, Principles, Algorithms, and Applications. Dr. Brown has been visiting positions across Europe, the USA, and Japan, and is a recipient of multiple awards for excellence in teaching and research. Now, I request Dr. Brown to kindly address the gathering with his wisdom on the topic of deep sleep using acoustic AI to access sleep disorder in the home. So due to time constraint, we request you to conclude the session within 20 minutes of time. Please, sir.
Okay, thank you very much for that. I'll just try and share my screen. Yeah. Oh, I've got permissions issue. Just give me a second. I just need to rejoin the call. Just give me a second.
left. पहले टाइम पूछो बात तो नहीं हो रहा हम थोड़ा कोशिश करेंगे
गोरी लोग ही परेशान
Hi. Can you still hear me?
Yes, sir, we can.
Okay, great. I think we should now be okay. Okay, does that look okay? Great. So thanks very much for joining me this afternoon. So yeah, my name is Guy Brown. I'm from the School of Computer Science at the University of Sheffield. And what I'm going to talk about is deep sleep, some work that we've been doing to use acoustic AI to assess sleep disorders in the home. And by acoustic AI, I mean machine learning systems that are based on recorded sound. So essentially what I'm going to talk about is how we can use AI-based systems that interpret sound to screen for sleep disorders. And I particularly want to focus on obstructive sleep apnea, abbreviated OSA. And also to focus on how those systems can work effectively in a home environment. So I'm going to start off by giving you some background on sleep disorders, then think about exactly what the problem is here and what the opportunity is for applying AI in this space. Could talk about approaches to screen for obstructive sleep apnea using acoustic signals, and then say a bit about how we actually evaluated and practically deploy these systems on smartphones in the home. And then finally, if you've got time, I just want to talk about some recent work which has just been accepted to ICASP this year, which is about improving the performance of our algorithms using multitask learning. So I don't know how much you know about obstructive sleep apnea. So, when we think about sleep disorders, we tend to think of them as just like a mild annoyance. Maybe we've got a bed partner that snores or something, and it's kind of almost kind of an amusing thing. But in fact, sleep disorders can be very serious and very debilitating. And obstructive sleep apnea is the most serious of these conditions, and it affects a very significant proportion of the population. There are various reports that suggest a range of incidence levels. Those vary by country when those studies have been done, but in the US, typically the reports say something like 24% of middle-aged men and around 9% of middle-aged women are affected. So men tend to be affected more than women, and also it's very much age-related. That's also clear, for example, in this data from India, where kind of the average prevalence has been estimated by Patanakek and all. And so what is this? So what actually it is, it's a collapse of the airways during sleep, and that leads to a lack of oxygen, hypoxia, in other words. And this often goes undiagnosed. Sleepers don't know that they have this. They typically know that they sleep badly, but they're unaware that they're going through this repeating cycle of the airways collapsing, them kind of unable to breathe, that being followed by an arousal, a disturbance in their sleep, and then back into sleep, and the cycle continues. So people sleep very badly, tend to suffer from fatigue. Daytime sleepiness is another implication, and that can be very serious if, for example, you have a driving job. In the UK, if you have a diagnosis of obstructive sleep apnea, you have to tell the vehicle licensing agency in the UK, because there is a risk if you are driving. And we know there are also really serious comorbidities here. So increased risk of stroke, heart attack, diabetes, high blood pressure, and so on. And the key to dealing with all this really is early intervention. If you can identify early that this is a problem, then you can make lifestyle choices and so on, which will really help to manage the condition. So how actually do you diagnose obstructive sleep apnea? Well, the standard test is something called polysomnography. So this would be done in a hospital sleep lab. You attach multiple sensors to the patient and measure brain signals, measure respiration signals and blood oxygen, and so on. This is expensive. It has to be done in a lab. It's quite invasive. You can see the number of wires that are connected to an individual. And people don't sleep in a way that's kind of typical. So there's well-known first night effects here. Really, you need to record over many nights to get decent data. But it's impractical to do that. So there are many advantages then to moving diagnosis and monitoring of obstructive sleep apnea into the home. And the particular approach that we have taken is to use smartphone-based solutions that are based on sound recording. These are low cost, and they're also non-invasive. It doesn't require anything to be attached to the sleeping person. So, you might be wondering at this stage why this is all relevant to Confluence. I think it is. As I said, our approach has been to develop these smartphone-based systems. This is quite a challenging problem. It's challenging in a home environment because of background noise, because you don't know for sure actually that the subject is going to position the phone, the sensors, in the way that you want them to. There may be other sources of noise present, like a bed partner. So it's really quite a challenging problem. Our approach has been to try and find ways of robustly doing this, and to do this in a way that allows us to express the results in clinically meaningful metrics. I think actually what I'm about to describe spans all the areas of influence, of interest to Confluence. So, you know, your conference is about cloud storage, which is a component of our system. Data science, well, analysis of subject data is absolutely key here, and engineering. And there are real challenges here in terms of the practical systems engineering issues. So our approach has been to put a smartphone by the bedside and to use that to estimate what is called the apnea-hypopnea index using recorded sound only. So this apnea-hypopnea index, or AHI, is the number of apneas plus the number of hypopneas over the total sleep time. So an apnea is a total collapse of the airways. A hypopnea is a partial collapse of the airways, which leads to a fall in blood oxygen, but not a complete stop to breathing. And the usual clinical measure to assess the severity of obstructive sleep apnea is to look at the AHI, and the unit there is the number of these events that occur per hour. So if you're a normal sleeper, then you would have fewer than 5 of those kinds of events an hour. Mild OSA, 5 to 15, moderate, 15 to 30, and severe, you're having more than 30 of these apnea or hypopnea events per hour of sleep. Okay, so what does the system look like? So we have a sleeping subject on the left, and I can use a pointer. Yep. So we've got a sleeping subject on the left. In order to get training data, what we do is also to record using a home sleep test. So this is a kind of a smaller version of polysomnography. It uses a few sensors to measure physiological parameters. We measure blood oxygen, we measure airflow through the nose, we measure movement of the chest. And that data is scored by a sleep technician, a trained sleep technician, to give us sort of ground truth training labels to say there was an apnea here, there was a hypopnea here, this was normal breathing. And from that, we can get a clinical estimate of the AHI, and we can also get training labels for different parts of the audio signal. So the audio signal is recorded by a conventional smartphone. We have a dedicated app that streams the audio to cloud storage, and also kind of so we do that for kind of data collection. Our aim, though, actually is to move this kind of processing onto the phone, and I'll talk about that at the end. Then we take this audio, we segment it into parts, we extract features. Those are used as the input to a deep neural network, and we use that to estimate the AHI using the sound only. So this home sleep test data is used at the training stage. At the inference stage, we are only using the acoustic signal. And from the acoustic signal, we evaluate whether there is obstructive sleep apnea present. So in terms of data collection, we've collected from 103 participants. As I said, each participant does a home sleep test, and you can see they've got an oxygen sensor on the finger, a chest band that measures movement of the chest, and a nasal sensor that measures airflow through the nose. In total, we recorded 157 nights of audio and scored that data. We had more males than females, and also, you know, the age was quite a large age range, around 25 to 71. The BMI, body mass index, around 31. So typically these were people that were overweight, with some into the kind of the obese range. And also we had a range of different severities. So on average, these were sort of moderate to severe, but quite a range from really no obstructive sleep apnea through to some very severe cases. So one there with 114 events per hour. So quite a range of data. Okay, so in terms of feature extraction, well, you might say, normally you're making sleep breathing sounds. If there's an apnea, then breathing stops. So maybe you could just listen for when the sound level goes low, when the breathing stops. But that's not feasible in a home environment because you've got background noise. Okay, so you need a different kind of engineering solution rather than spotting periods of relative silence. So our approach has been to try and classify quite long time windows, around 30 seconds with a 10-second shift. And the reason we do that is because there are characteristic cues before and after an apnea, which are much easier to detect. So if you look at normal breathing, so this is like a time frequency plot here, time on the horizontal axis, frequency on the vertical axis, and the color relates to the amount of energy that is present at that particular time and frequency. This is normal breathing, and you can see a regular sort of series of stripes. In the bottom one, there's some louder events here, which is actually snoring. And you can see that during the apnea, there's a period of relative silence. So the person's unable to breathe, they're struggling for breath, there's no normal breathing, and it's relatively quiet. But there is still some background noise. But when they come out of the apnea, then typically there is grunting or gasping sounds, and those really help to kind of cue that an apnea has occurred. So that really is a way of spotting, you know, that kind of pattern. So essentially, we make sound recordings at a rate of 16 kilohertz. The acoustic features are MEL spectrograms, and we have 64 filter channels between 70 hertz and 7.5 kilohertz, as you can see here. So the neural network is pretty conventional, really. It's a convolutional neural network. We've experimented with various architectures and are still doing so. But at the moment, with the limited amount of data that we've got, this is giving us the best performance. So it's a CNN, 3 layers, 3x3 kernels, 16, 32, and 64 filters in successive layers. And finally, we kind of flatten the convolutional outputs, pass them to a fully connected layer, and then classification is made by a single output neuron with a sigmoid response, and that makes a binary decision. So do we have an apnea-hypopnea event or do we not? So to evaluate the system, as I say, what we're doing is we're estimating the apnea-hypopnea index and comparing that against those reference transcriptions of the home sleep apnea recordings that we made. We use tenfold cross-validation and compare against a baseline system which is using information from the blood oxygen saturation sensor only. So that was the sensor that you saw attached to the sleeping subject's finger. It's called a pulse oximeter, and that gives you an estimate of the blood oxygen saturation, in other words, the amount of oxygen, percentage of oxygen in the blood. So we also developed a classifier based on that physiological feature using delta features. Those approximate the first derivative of the SpO2 signal from the oximeter, and then we pass those to a classifier which is again a CNN and has a similar architecture to the acoustic classifier. So essentially then we can compare performance using sound only, and then using a physiological parameter that we've recorded, which is something like a kind of clinical standard. And in fact, there are some variations in the sensitivity and specificity of the two approaches. So the sensitivity is the proportion of true positives that were correctly identified, and the specificity is the proportion of true negatives that were correctly identified. You can see that both of those two kind of systems are in the same sort of ballpark, and we have slightly better specificity for the audio system than we do sensitivity. Another thing to point out is that that result is for an AHI cutoff of 30. So in other words, what we're doing when we report that result is saying that that is really for detecting no obstructive sleep apnea versus severe sleep apnea. The performance of the model is not quite as good if you're trying to detect mild or moderate sleep apnea. So for example, we express this as the area under the curve, and you can see that performance kind of gets better for the acoustic and for the other system pretty much, based on the thresholds that you're trying to detect. So in other words, it's easier for the system to discriminate a severe case from no sleep apnea. It's harder for it to discriminate a mild or moderate sleep apnea diagnosis from a normal case, and that's probably what you would expect. Another way of quantifying this is to look at what are called Bland-Altman plots. So this looks at the average of the estimated AHI and the true AHI, and then the difference between those two measures. The dashed lines are the 95% limits of agreement. So each of these is data from a single night, and you want those within the gray period within those dashed lines. And you can see actually performance of the acoustic-based system and the SpO2-based system is pretty similar. So we think we've got a kind of pretty good alternative which doesn't require any kind of sensors being attached to the patient. In terms of practical deployment, we have actually deployed this in an app that's available through our partner PFL Healthcare. The model actually has around 6 million parameters, and that's therefore something that can be implemented on a phone with GPU acceleration. We can do that in close to real time. So the big advantage of doing this, of course, is that if you can do the machine learning on do the inference on the phone, then all the audio can stay on the device. And clearly there are lots of issues here around user privacy. So it's great if we can avoid using cloud storage at inference time and just do all the machine learning on the phone, so that all that kind of personal audio data stays on the device. Just very briefly, recent work that we've done, which has just been accepted to the IEEE ICASP conference this year, looks at improving the performance of that classifier using multitask learning. In other words, can we improve performance by jointly learning an auxiliary task? And what we've done is to estimate the respiratory effort signal directly from sleep breathing sounds also. So this is the chest band that you can see just around here. As you breathe in and out, there is a strain gauge within that which measures the amount of effort, and it's an approximately sinusoidal signal. You can see it in the bottom of that slide. And if you look at the breathing sounds, you can see there is some sort of correspondence between the breathing sounds and the respiratory effort. So our point is not that you need the chest band at inference time, you wouldn't. It's about improving the performance of the audio classifier by learning this additional task. And we use a latent space fusion approach. So we combine embeddings from the audio classifier with those that have been inferred from the respiratory effort classifier, and show that if you do that, you can actually improve performance, particularly in those mild and moderate discrimination cases, which the previous classifier didn't do quite as well. So the latent fusion approach, we get something in terms of the area under the curve now, which is really comparable with the performance that we would get from a physiological sensor. Okay, so just to summarize, obstructive sleep apnea is a pretty serious condition. There is a real need for low-cost, non-invasive screening solutions that are suitable for use in the home. And we believe that AI systems that analyze sleep breathing sounds offer a good way forward. We can demonstrate performance that's competitive using a home sleep apnea test. But the great advantage is that whereas that test requires various sensors to be attached to the sleeper, our approach doesn't. It's entirely non-invasive. And certainly doing that only, we've shown good performance for discrimination of severe OSA from normal sleepers. We've also shown that performance for mild and moderate OSA can be improved by learning an auxiliary task, and that was estimating respiration effort from acoustics. Just to acknowledge that what I've reported today is the work of a large team, in particular my colleague Dr. Ning Ma, who's a senior lecturer, has done a lot of the technical work in this project. Also, Zhao Zhu, Chao Yunyu, Hector Romero, and Elizabeth Hill have all made substantial contributions. And the papers that I've talked about are there. One back in 2022, which was our first study, and as I mentioned, the most recent work is published in ICASP this year. Okay, that's all from me. Hope you found that interesting, and thank you very much for your attention.
Extraction architecture used. Seconds. Thank you so much, sir.
Sir, thank you so much. Sides, we are so grateful for your insights today, the students, and for the research for this. and the token to accept this. Sir, am I audible? Hello?
Hello?
Hello? Am I audible, sir?
Yes, Neha, you are audible.
Hello? It's not audible, sir. Hello?
Dr. Neha, you are audible.
Hello? Yes, okay. Thank you so much. कोई नहीं फिर।
Next start.
Hello. Okay. Keeping the flames of insightful discussions lit. Hello, sir. Hello, sir. Dr. Sanchez, am I audible?
Hello, good morning. Can you hear me?
Yes, sir. Yes, sir. Am I
All
audible
right.
to you?
Yeah, right now you
Yes, you are
are.
audible.
Okay.
Hello, Professor Sergio, Dr. Garima this side. How are
Hello,
you?
Dr. Garima. Great, thank you.
Thank you for joining the
Very
session, sir.
yeah, happy to join again Confluence a year more. Pleasure as always.
Okay, so moving forward with this session and keeping the flames of insightful discussions alight, I would now like to welcome Professor Dr. Sergio Marquez Sanchez. It is our great privilege and honor to have you here with us, sir. Professor Sanchez is an industrial engineer since 2017 from the University of Salamanca. At the same university, he obtained his technical engineering degree, specializing in mechanics in 2014. At the same time, he obtained a master's degree in design, delineation, and finite element analysis with the Autodesk Inventor, SolidWorks, and CATIA V5. He has worked as a teacher of robotics, programming, and 3D design, as well as participating in the various projects of entrepreneurship, R&D, and product design in the fields such as education, robotics, wearable technology. His research interests include smart textiles, electronic textiles, robotics, CNC technologies, PLM software, and circuit printing. Now, I request Professor Sanchez to kindly address the gathering with his insights on the topic of AI, IoT, and deepen for urban water resilience, the AquaSave architecture for measuring and monetizing water efficiency. With all due respect, sir, due to time constraints, we request you to conclude your session within 20 minutes of time. Is that okay? So you're not audible actually, you're muted.
All right. Yeah, sorry.
Yes, it's fine.
I was telling that I going to share the screen. I'm perfect about the 20 minutes.
Yes, sir.
All right. So I am sharing already my screen.
Yes, it's visible now.
Perfect. All right. So, well, first of all, thank you for inviting me a year more here to Confluence. I think it's the 6th year that I attending to the Congress. So, well, today I want to cover a topic that is the topic that I was working for the last years, that is deepening the centralized physical infrastructure. And in a way, this topic is connected as well with artificial intelligence and Internet of Things. And in my case, as soon as I am working in my own project related to deepin, I would love to show you how we are using this technology to monitor and track water and also save water in different contexts, and how, thanks to the technology, we are able to monetize as well the efficiency. So, first of all, it's important that everyone understand about this new concept, deepin. So what this means is decentralized physical infrastructure. Nowadays, when we are thinking, for example, in telecommunication, there is telecommunication companies that deploy hardware antennas for offering the coverage in different regions. That means that they need to spend a lot of money in order to deploy these antennas and also operate and maintenance the antennas. That happen with many other topics as well. Companies, governments, they need to spend thousands of dollars, euros in deploying infrastructure, and there is also attached some expenses for maintain this infrastructure in a good state, available and with good performance. So this technology, deepin, is based on the community. The community or the population is the ones that are going to deploy the infrastructure. In the case of telecommunication, will be the ones that deploy the antennas and do the maintenance and the operations required to have the antennas working properly. And another interesting thing in this technology is that is connected with the technology of blockchain. So from that, we decentralize the infrastructure in the way that everyone that participate in this infrastructure could have also a reward because of connecting economies through this concept. These economies could be crypto economies, or could be economies that reward in other ways, in benefits, in discount, whatever the project decide, based on the services that are providing as well to the community that is providing this infrastructure. So it's as simple as, if me as a project, I give everyone the possibility to deploy my devices, my infrastructure, I'm going to have less cost than if I need to do everything myself. So that means that I can give from the benefits that I obtain thanks to the services that I am providing through the infrastructure that is deployed. I can reward, or I can give benefits, the ones that are allowing this. And as you can see here in this flywheel, there is deepin platforms, there is deepin apps, there is deepin protocols, where we generate a wheel, and here everyone could win. Okay, there is investors that could add value to the tokens. There is miners that could, or deployers that could deploy this infrastructure. There is third parties, developers, or that want to obtain this information. Thanks to this infrastructure that we are generating, there is a possibility to generate applications. Yeah, it's very important to have a good community that care about the mm, good develop or good deployment of the project in order to maintain these services in the best way. So right now it's improved more than this, but as you can see, there is similar concept of deepin is in different fields, not only in mobility networks, that the ones wireless networks in this case, this is the ones that I was mentioning before, no antennas that offer different kind of coverage that mm, could be LoRaWAN, 5G, any kind of protocol that require to have an infrastructure, a network. So there is also other projects that are connected to environment, energy, um, geopositioning, robotics, data, energy networks. So uh, depending of if it's physical infrastructure of we are talking about have decentralized infrastructure that also provides services, we found some different projects that are right now using this concept. So I would like to, first of all, I'm going to move to here. And here you can see how, for example, in the case of Helium, that was one of the first projects in Deepin, actually, before this concept exists, Helium was already there, and we needed to find a name to call this kind of technology. So Helium in total got 1 million antennas deployed in the entire planet. Right now, this number is reduced, is 200,000 antennas deployed in the planet. And this kind of antennas is offering coverage LoRaWAN, okay? So thanks to this, we have a network where there is, as you can see here, the hexagons, where depend of the number is the number of antennas that we can find in this hexagon, and some cities of the world are full of these antennas, and these antennas belongs to users that are receiving as I was telling, rewards in this case. And at the beginning, Helium started with LoRaWAN antennas, and right now is also offering 5G antennas that allow the users to use their network, okay? And there is some telecommunication companies that are doing partnership with them in order to use this infrastructure. So they are getting some incomes thanks to this, okay? And you can see here the earnings that in this case, this hotspot, how is call it, had in the last days. Also, there is here the activity, and there is some information that you can see through the Explorer, okay? There is as well projects like Weather's XM. I would like to show you as well. I don't know. Well, while this is charging, I don't know what happened. I will show you as well Event Mapper. This is same concept, but connected to cameras that are installed in cars. And through this, we can analyze the state, how good is the roads. So saying that we have Google Maps right now to have a 360 view of the road, and also we can know, thanks to this, the Google Maps, if there is traffic jams or things like that. So this is the same concept, but with the accurate cameras that could be installed, and this data is later sold to these companies like Google that could be interesting. So, for example, here there is the example of Japan, and in Japan, I can select any region of Japan, and you can see here in this region the total amount of roads that they measure, and there is some information. This is the information that I can obtain without paying, but if I pay, they have actually the images and many other things. And in the case of Weather XM, let me check here if I can show you. Yeah, this is the same concept, but in this case is with environment sensors stations. So through these stations, for example, you can see here one of the stations, big water scarcity during months of the year. And yeah, the increase of the population also means that the demand is increasing and the supply is not increasing. So we need to attach technologies that could allow us to have a better knowledge and better decision making. So in a city, normally what we can find is about these different points, and sometimes the network is not so accurate. So it's interesting to use technology that allow us to have real-time monitoring and measure the parameters interesting, like the conductivity, the flow level, pressure, the temperature, the pH, or turbidity. So there is a huge opportunity here to have a more competitive network if we found the right technologies. Okay, so as you can see here, in this case, using different kind of sensors and deploy these sensors in different points of the network, we can have a better decision making. There is also some inefficiencies in the houses. For example, all the water that we use and is not super dirty, like is still possible to reuse this water. It's great to have systems that allow us to reintroduce the water that we are using, for example, from the showers or when from the sink, okay, to the other systems in the house, for example, for irrigation, the plants that we have outside, or um, any other use, no? So in these cases, it's interesting as well to attach technology that allow us to understand what is happening in the house and have a smart house that have an use in an efficient way all this water that is still possible to give a use. Okay. In our case, actually, what we are doing is we are working with all the water that we lose while we are waiting for the hot water. Okay, so there is a big inefficiency there, and thanks to our technology, this device, we install the device under the sink, and we are able to measure different parameters that also are going to be interesting for the water supply companies, municipalities, okay? And is the user the one that installed this under the sink, but with the interesting feature that as soon as we ask for the water, we reintroduce the water using the cold water pipe to the heater, generating a closed circuit and not allowing the water until to fill until the water is ready. So this impact in the bills, this impact in savings, this impact in have more efficiency, reduce the consumption, and this yeah allow us also to measure different other parameters like detect, for example, leaks and losses in the water distribution pipes. Saying that we have this device, as I was telling, we can have other devices that measure the information about water in other contexts. And the idea is generate a network like what I was showing with the other projects, but in this field, in the field of water. So from this, as soon as we are having devices deployed that we can gather this information, we can send to our platform. Also, we can have a mobile app where users could monitor and track everything in the platform. We have the possibility to generate reports, dashboard from all the data information that we collect, okay, from the different devices, as you can see. Also interesting about the Explorer, no, that we could have an Explorer where we can visualize all this information. We are generating as well, as soon as we have credits, like savings, we can generate credits from this that could be applied to the compliance and the voluntary carbon credit market. Okay. Yeah, interesting thing in our case that we just not we have a benefit, direct benefit in the real gel for the users. So in the case of an antenna, okay, if I don't receiving any reward, for me it's not interesting to have the antenna working because it's also using my electricity, have yeah, I need to have time to allocate to maintain this. In our case, as soon as we have technology that is interesting, for example, in the case of the savings, and we generate certificates, yeah, we have a differentiation in between other projects that you can find in the field of deeping. Yeah, interesting that we also are right now deploying these devices in different pilots. For example, with the Balearic Islands in Spain. So from there, we are validating the technology and we are expecting to start selling and deploying these devices also all around the world and connecting all these technologies that we are talking. I was talking about blockchain. Blockchain is valid also for the traceability and verification of the data information that we collect. Also, we are using smart data analysis through different algorithms for detecting, for example, the leaks and losses in the water distribution pipes, the general ones. So from this, we will have better decision making. We will optimize the systems. There is many benefits. That's everything from my side. Thank you for this space, and yeah, happy to answer any question that you could have. Or if you want to connect with me directly, you have here my email address. Thank you.
Hello, sir. Am I audible now?
Yes, you are.
Yes, sir. So, uh, so we are very thankful for your interactive session. It was definitely a great awareness session on water scarcity problem around the world. And you also enlightened us on the role of community operated sensors in managing water supply. The technology of DeepIn is certainly groundbreaking in this field, and it was clear from the interactive dashboard presentations. And we also learned about various platforms where we can actually utilize it. And with the hope of adopting similar infrastructure here in India, I would now like to invite Professor Dr. Neha Tyagi to present a memento of gratitude to you.
Thank you. Thank you, sir. Your session was very impactful related to the scarcity of water in the whole world. So obviously, students have to think about this project. So it's a very nice, and thank you so much. Here I'm presenting the Tulsi sapling as a gratitude. So please accept it.
Thank you very much.
Thank you. Thank you, sir.
With this, we conclude the session. We hope it was enriching and informative experience. I once again, on the behalf of Fraternity of Amity University, Uttar Pradesh, thank all the guests, dignitaries for their significant presence. We would also like to thank the students for their cooperation. Thank you very much.
Thank you. Have a great day.
No, no, no. Now we are moving.